Yeah, so for whole, right, the y equal x plus 1, of course, the graph will just look like this. Y-intercept 1, gradient positive 1. Okay, so far?
Okay.
But now, with the knowledge of functions and the idea of domain, you cannot divide by 1. Cannot divide by? Never divide by?
0.
0, right? So let's say we upgrade this. So instead of x plus 1, we purposely make our life difficult by introducing our x minus 3 at the top, x minus 3 at the bottom. Well, you must argue that, hey, this can cancel, right? So it's just x plus 1. Why do I want to do that? Why do I want to make it so complicated? Multiply top and bottom by x minus 3. Because when you give this as the original form, what happens is that there is a denominator here. You're dividing by x minus 3. So x cannot be equal to 3, right? Exactly. So what happens if you try to draw this graph? What you'll get is, let me just copy and paste the graph. At all the other points that's not equals to 3, right? The y value is just essentially x plus 3. Oh, sorry, it's x plus 1. Why am I saying? X plus, I very useful, x plus 1. So it will still look exactly the same. However, at x equals to 3, you equate denominator to 0, not equal, then you get x not equal to 3. That means that when x equals to 3, what's the corresponding y value if it was the original x plus 1 graph? I mean, it looks exactly the same, right? So we should use back the x plus 1 function. When x equals to 3, what happens to your x plus 1? It's equal to? What do we get? Y equals to 3 plus 1, which is 4. So we get 3, 4. Does that make sense? 3, 4. So where is 3, 4? It's somewhere here. Then that means we'll have a hole there. Because if you try to substitute x equal to 3, yes, you should predict it should be a 4. Right? But if you try to sub in directly to this guy, you end up with a 0 over 0 and then a 4 here. 4 times 0 divided by 0. This is what we call an indeterminate form. It's time for you to learn this already. It is finally time. Indeterminate form. In a scientific calculator, as well as GC, you type in 0 divided by 0, it will tell you math error or something along those lines. In the future, you'll learn about something called L'Hopital's rule, which will help you to evaluate this kind of fraction, which involves the idea of limits. Let's not go there yet. But the rough idea is, limit is basically looking at what happens as I approach the graph from the left and from the right. If you put in x equals to 1, x equals to 2, x equals to 2.1, 2.2, 2.3, 2.1, 2.2, 2 point something very, very close to 3. What's the corresponding y value? What's the corresponding y value? What's the corresponding y value? You realize that it gets very, very close to 3.9. And if it's starting from 4 and then you slowly drop your way down to 3.5 and then eventually 3.1, 3.01, 3.001, then what's the corresponding y value? Oh, my y-axis is too short already. Let me make it a bit longer. What's the corresponding y value? So we see that it will become 4 point something, for example, 4.2, and then 4.01, 4.001, 4.0001. What's what we call the limiting behavior of the y value? You see, as it increases, as it decreases, it's getting closer and closer towards 4, right? But can it be exactly 4? The answer is no. Undefined at 3. X not equals to 3. Because of the rule, you cannot divide by 0. But yet, even though we cannot substitute x equal to 3, we still know that eventually, you look at the graph, it's gonna reach 4, right? It has to be 4. So this is when we say the limit of that expression, just x plus 1, but I purposely multiply x minus 3 at the top and bottom, as I let x approach positive 3 is exactly equals to 4. Is that clear? The idea of a limit? Good. Okay, you learned the idea of a limit from a graph. Okay, that's the idea for a hole in the graph. I think what he was trying to say was that don't just blindly put a hole at the x-axis. No, it's supposed to be x equals to 3, sub into the correct function. In this case, the correct function being x plus 1 without the x minus 3, cancel off. Sub in x equal to 3 inside, then you end up with a 4. Then you plot a point at 3, 4, but you must draw a hole, an empty circle, to mean that you're excluding that point. Is that okay?
Okay.
Yeah, that's the key idea. Then after that, about this even and odd idea. Okay, let's say you start off with y equals to 1 over x. Then clearly x not equal to 0, right? So how does the graph look? It looks like this and this. Can you see that?
Yeah.
There is an asymptote, what we call asymptote, at this guy y equals to 0 as well as that guy x equals to 0. So what he's saying about the odd, right, means that here you can think of x as the same as 1 over x as 1 over x minus 0 to the power of 1. Can you see that? And 1 is a odd number. And whenever you have a denominator with a factor to the power of an odd number, the graph will look something like this. Around the x equals to 0. You equate this to 0, you solve for x, you get x equal to 0. Around this vertical asymptote, the graph will move closer and closer towards it. But there's only 2 ways to go nearer to it, from the right or from the left. And then, okay, actually 4 ways. From the right, then you can either decide you want to go up or you go down. From the left, you can either decide to go up or you go down, right? What he's saying is that when it's odd, the direction will be different. On the left side, it will be downwards. For the right side, it will be upwards. Okay?
Oh, okay.
Different direction. Then approach the vertical asymptote in different directions, or more like approach the, not the vertical asymptote, no, more like approach plus infinity, negative infinity of the vertical asymptote in different directions. So one of them goes towards positive infinity, the other guy goes towards negative infinity. Does that make sense?
Mm-hmm.
No space. I want to draw an arrow. Okay, then this one goes up to positive infinity, this one goes down to negative infinity. So they are opposite. This happens when you have odd power. Okay, opposite direction when you have odd power. Is that okay?
Okay.
Yeah, then what happens if it's a square? What happens if it's a square? Okay, 2 part 1. 2 part 2. What if we have y equals to 1 over x squared? You already know how to draw this graph? You already know how to draw this graph? It's a volcano. Then what's the pattern here? This time, you got, I'm going to purposely write as 1 over x minus 0 first, then square. What's so special about a square? It's an even number to the power of a factor at the denominator. Then you notice that they both go towards the same direction, positive infinity. What happens if I consider now part 3, y equals to negative 1 over x squared? It's negative 1 over x minus 0 bracket power 2. So that means that, okay, why did I put x minus 0? It's because I want to follow the pattern. Equate denominator to 0, then solve. I get x equals 0. That's why I have the vertical asymptote x equals 0. And you approach the vertical asymptote in the same direction, both going towards positive infinity. How about this other case? If it's negative, or you just reverse the direction, right? It goes downwards instead. So they both go towards the same direction, negative infinity. And the asymptote is still x equals to 0. Is that okay?
Yeah.
Good. So, to be honest, I didn't learn this idea, and you don't need it. Why? Because if you have the function, you can just plot a point. Think about it. You know that there's a vertical asymptote, so there's from the left side, it's either going to go upwards or downwards. Okay, there's also a horizontal asymptote for some. Yeah, y equals 0. Okay, I don't talk about the y I don't talk about the horizontal asymptote first. Just trust me that there is. Then there's only 2 ways for you to draw a smooth curve. A curve that will approach the asymptotes. Let me redraw this without the idea of even and odd. If I have a horizontal asymptote y equals to 0 and vertical asymptote x equals to 0, how do I draw the graph? There's only a few possible curves, right? It's either if you want to approach the horizontal asymptote, it's either this way or this way, right?
Mm-hmm.
If you want to approach a vertical asymptote, it's either this way upwards or that way downwards. So that means there's only two possible curves now if you connect them. This one or this one at the top or at the bottom. How do you decide which is which? You literally have the function, right? So why don't you just substitute a point? Sub a point, x equals to, let's say, -1. What do you get? Y equals to 1 over -1 squared, which is +1. Positive, then can you still be at the bottom? No way, right? So you have a point here, -1, +1. Then from there, you can eliminate. This guy must be out. It must be the top curve. Is that okay?
Okay.
Then how about the right half? Same logic. You have an asymptote here and an asymptote there. So you must approach. You either approach this way or this and this way, or that way and that way. So that means you can only have this type of curve or that type of curve. But which is which? You see, this fails the vertical line test. One x value, you get two different y values. So you must only select one of them. How do you decide? How do you decide?
Sub x equal 1.
+1. Then what's a y? 1 over 1 square, which is 1. +1.
On top.
So top or bottom? Pick the top one. So you see, you don't really need the odd and even function to realize that you have these two curves. Just sub in a point.
Okay.
I didn't. This is how I learned it. This is how I learned it in levels. I didn't learn about this even idea. Okay. But of course, it's an interesting pattern. Let me show you the Desmos demonstration now about the even and odd idea. Let me get the link. I just sent it last night. Okay, take a look. Can you see the screen? Yeah. So over here, what's going on is this function, right? I just decided to add on a +2n here. Okay, ignore. If we just look at this n value, n equals 0, correct? Can you see n equals 0? Is it too small?
Now I can see.
Okay, make it bigger. N equals to 0. Then what we have is, if you start with 0, it's essentially power 1, power 2, power 1, power 2. Let me simplify it in another screen. So I'll just remove the n. Okay, it's essentially this guy. Then what the prof mentioned in that video is that when you have, if you look at the denominator, odd powers, then you go in opposite direction. You equate this x plus 3 to 0, you get x equals x equal what? X plus 3 equals 0. So bring the +3 over, x equals to? Hello? X equal to what? I cannot hear you. Hello, Brandon? Hey, where are you? Mic test, can you hear me? I cannot hear you. I cannot hear you. Mic test. Oh, you.
Hello.
Mic test.
Hello.
Can you hear me? Yeah. I can hear you now. Can you hear me?
Yeah.
Oh, okay. Audio not good. Not sure why, but okay. So what was I saying? I was saying x plus 3, this one equate to 0, so x equals to?
-3.
Oh, you are replying me already, but the audio not connected. Okay, so yeah, x equals -3. That's why if you look over here, you have this purple line, which is x equals -3. Can you see that? 0, that's an asymptote. Right, same thing with the other guy, x minus 1, you equate to 0, solve, and you get x equal to 1. That's a vertical asymptote, x equal to 1, the black line. Okay?
Okay.
Then here, what he's saying is that when it's a power 1, odd power, it will go towards the asymptote in different directions. So x equals -3, you notice that the red line is going upwards and downwards towards positive and negative infinity. That's what he means. I hope that clarifies. Odd power, then you go towards the asymptote in different directions. Then for the other guy, x minus 1, resulting in asymptote x equals to +1, you have an even power. Even power means that you will approach the asymptote in the same direction. Either both go towards positive infinity, the graph will approach the asymptote in the same direction. Either both goes towards positive infinity or both go towards negative infinity. So over here, you see both goes towards negative infinity. When you go towards the black line, you're going downwards, Right, the y value getting smaller and smaller. Okay, so in order to generalize this, I just decided to make, just for fun, I make it into plus 2n. Because now if I change the n to 1, let's see what happens. Calculate it yourself. If you introduce n equals to 1, then 2 times 1 gives you plus 2. So 1 plus 2 will give you odd power 3. So at first it was 1, which is odd. After I add on 2n, it's still odd. Likewise for the other powers, I just decided to add on a 2n so that the parity is still the same, meaning odd or even. Right? If it's let's look at the x plus 3 here. Same story. If it's a 1, you add on 2n. 1 originally was odd already. You add on 2n, in this case, n is 1, means you plus 2. So 1 plus 2 gives you 3. This 1 plus 2 times 1 is a 3, which is still odd. How about this other guy, 2 plus 2n? 2 is even. You add on 2n, it's still even when n is 1. Is that okay? So this is currently 2 plus 2 times 1, which is 4. Right? Then let's look at the graph. What happens? I show you before and after. Maybe I zoom out first. Before, after. Before, after. You see it still follows the same pattern. Towards the asymptote. Towards the purple asymptote, it goes in opposite direction. Oh, disappear already. Oh, cannot, too big. It goes up and goes down. Then towards the black one, it both goes in the same direction. Just that the function looks a little bit funnier on the right side when you change the power. Okay, so the general idea that you have odd or even affecting the direction of the approach towards the vertical asymptote, it still holds, even for higher powers. But honestly, this is a new idea I didn't encounter before. So don't worry too much about it. Try the other technique I'm teaching you, which is to just plot points. Okay.
Okay.
Yeah. And in his video, he also mentioned that there sometimes can be turning points, maximum, minimum point, which at that point in his video, the students have not learned calculus, meaning differentiation, finding maximum, minimum point. For you, you learned already. And in the A-level syllabus, we also teach it already. So you need to differentiate, equal 0, solve for x, besta, to find maximum point, minimum point. Okay?
Okay.
I think you're probably expected to know this. Table is first derivative test. Draw a table. First derivative. Of course, you can also go for second derivative test if you want. Okay, good. So let me teach you on how we usually draw graphs in A-levels. We don't use the odd and even idea, actually. And it's also excluded from the syllabus, the whole idea. So let's start with this first example. The examples. Okay, which graph do you struggle to understand?
I
think it's this one, right? There's a whole idea.
Okay. Yeah.
Maybe we should start with that. Okay. Start with the complicated one. Okay, 5, 6, and 7. Okay. So let's start with that. Example number 4. We have, let me copy the function first. So what you realize is that there's a clever trick. You can factorize the numerator. So typing in a calculator, get the roots and then work backwards. What you get as the factors, you will get x minus 2 at the top and then 2x minus 1 at the top as well. Right? Then x squared minus 4, you have to be clever and realize that 4 is the same as 2 squared. So you get x minus 2, x plus 2. So you get x minus 2 times x plus 2. And then, oh, magic, the x minus 2 can cancel away, right? So actually the function is 2x minus 1 over x plus 2 most of the time. 99% of the time, it is just actually this function, except for the case when x equals to 2. When x equals to 2, this fella equals to 0, you'll end up dividing by 0, which will cause problems. So that's when we introduce what's known as our at x equals to 2. a whole happens when you can cancel off common factors, but you follow the same procedure of equating the denominator factor to 0. Okay? But you must find the corresponding y coordinate. So what's the corresponding y coordinate? You use the remaining function, 2x minus 1 over x plus 2. Then this will be 2 times 2 minus 1 over 2 plus 2. That's just 4 minus 1, 3 over 4, right? So that means that we will have a whole at x equals 2, y equals 3 over 4, right? Then let's just draw the graph now. So when here is how we usually do it in A levels. When you have improper fraction, you see power 1, so it's improper, right? What we do is we do long division. So we just take 2x minus 1, divide by x plus 2. What do we get? 2, we get 2x plus 4, minus bracket, bracket, we get 0. -1 minus 4 is -5. This is the remainder. So this is else equal to 2 wholes plus -5 remainder divided by x plus 2. Then from here, we can already see, we can study what's known as the limiting behavior already. What happens if I let x go towards a very big positive number? What happens to your y? What will it reach? The arrow there means approach. Get closer and closer towards, but never equal. Focus on the piece by piece. Is the 2 affected by the x?
No.
No, so it remains as a 2. Plus, now let's think about this guy here, -5 over x plus 2. What happens when x gets bigger and bigger? You get
smaller number.
a smaller number, 10 plus 2, 100 plus 2, 1,000 plus 2, 1 million plus 2. But it goes, the value goes towards what?
It's
always negative.
Negative.
Negative. Okay, you just sub in a few values like -5. Okay, we try out. -5 over 10 plus 2. Let's just increase it straight away to -5 over 1,000 plus 2. And you increase it to 1 million and power 6 plus 2. Then increase it to 1 billion and power 9 plus 2. What happens? Look at the values.
You're minusing a really small number.
Yeah, okay. So essentially it's getting closer towards 0. Let's just show it at least one time. Nope. Fraction. Is my calculator showing?
No.
Oops, I need to change this. Thank you. Okay, let me try again. Yep, I think it should be showing now.
Okay,
so we get -0.416. Then the next one will be change to 1,000. What happens? -0.00499. Then the next one, what happens? Very, very small. So this one, 10 to the power of 6. 1 million plus 2. It's -0.0000049. Okay, so it's very, very close to, very, very close to
0.
0. So when you go to infinity, what happens? When this x becomes so huge, what will you approach eventually? You round off to 3SF, round off to 4SF, round off to 5SF. It's just gonna become 0. Okay? So at infinity, what do you think happens? What does this thing become?
0.
Exactly. It is equal to 0. Then it will be equals to 2. Another way of phrasing this is the limit of 2 plus blah, 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 as x approaches infinity is exactly equals to 2 plus 0, which is equals to 2. Okay, this is using limit law. Sum of a limit is the limit of a sum. Now, when you take the limit of two things added together, you can take the limit of the first guy plus the limit of the second guy. 2 is not affected by a limit. Okay, maybe I show the working. So what we have is, my arrow. This guy, it becomes the limit of 2 as x goes to infinity plus the limit of the other fraction. So you sort of distribute the limit. It looks exactly like the differentiation, right? You can differentiate term by term. This one you can limit term by term as well. This is independent of x, so it just remains as a 2. This guy goes towards 0, so it becomes a 0. 2 plus 0 equals to 2. So what does this really mean? It means that as the graph goes towards a very big positive number, it will approach 2. But it will always be slightly below it. Why below? Because there's a minus sign over here. It's always going to be 2 minus away 0.00499. Or it's going to be 2 minus away 0.00, how many zeros, whatever, 5. So it's always slightly below 2. So you can imagine how the graph will look already. There will be a y equals to 2. Then it's always slightly below it, but it's getting closer and closer towards it. Can you see this pattern? Okay, good. How about when it's going towards a negative infinity? Then we have to think about it. So limit as x goes towards negative infinity of 2 plus minus 5 over x plus 2. Again, same trick. I'm going to skip a step. I'm just going to write down 2 straight away. Then after that, take a limit as x goes towards negative infinity of minus 5 over x plus 2. I'm supposed to write down limit as x approaches negative infinity of 2, but it simplifies to just 2 because it's independent of x. Following so far?
Yeah.
But here I'm just changing it to negative infinity. This x arrow negative infinity is saying x is getting closer and closer towards negative infinity, but never exactly equal. Then we see what value this function will approach. So let's just do the same experiment. Now this time it's negative 5 over negative 10 plus 2 versus negative 5 over negative 1000 plus 2. You make it smaller and smaller, the x. Then negative 5 over negative 10 power 6 plus 2. And then so on. I think this is good enough. What happens? What happens? Let's just double check with a calculator. I just gotta change all of them to negative. Let me try negative 10 plus 2. Okay, I get positive 0.625. Negative 1000 with 10 power 3. I get positive 0.00501. And then I change this to power 6. What happens? It's still positive, but it's very, very close to very close to what? 0. Yes. Oh, so that means that it's a very very close to 0, but always slightly positive. So essentially, this is the limit will be 0, yes. So it will equals to 2, meaning that the graph will eventually approach y equals to 2. Oh, here is y equal to 2. You're gonna approach it if you sub in a value of x, which is very, very small. But it will always be slightly above I, because it will become the value of the expression will be when x equals to negative 10. When x equals to negative 10, the y value is 2 plus 0.625, which is slightly above 2. When x equals to negative 1000, what's the corresponding y value? It's 2 plus 0.00501. When x equals to negative 1 million, 10 power 6, the y equals to 2 plus 0.0000050. So it's still gonna be, it's still not equal to 2, but it's always slightly above or below. When you see plus sign, it means it's above or below. You plot a point. 2 plus 0.625. 2 plus 0.005. 2 plus 0.00050. It's always slightly above, right? So that means that the graph will go towards it from above like this. From above, not below. No? Simply because you plot a point and you realize it's positive. But now let's continue. There's one more asymptote I haven't discussed yet. So let me just clean things up a bit. Let me rewrite this without so much details. This time I simplify into this guy. All I need to do is to say x approach infinity, y approach 2, x approach negative infinity, y also approach 2. But this one I'll just say from below, another guy is from above. So I can draw a quick sketch already. Y equals to 2. From above, when you go from towards negative infinity, so it's somewhere like this. Then from below, so it's something like this. Okay? Clear so far? Good. That's not enough because now we still need to deal with what's known as the particular asymptote. So let's see. You always want to make the denominator equal to 0. Okay. So x plus 2 you equate to 0, solve you get x equal -2. This gives you the vertical asymptote over here. Then that's when you simply plot points. You don't need to think about odd and even, just plot points. You see something slightly towards the left of -2, right? You can plot a point. So let's say x equals to -1, then you find the y value. What will it be? It will be, there's no issue with -1, right? You won't divide by 0 here, right?
No.
No, so you can just use the simplified version of this guy and sub in with -1. So 2 times -1 minus 1 over -1 plus 2. This gives you -2 minus 1 minus 3. -1 plus 2 is +1. You get -3. So if it's, did I calculate it wrongly? Let me see. -3. Sorry, let me double check something. Oh, sorry. I was thinking of a value that is less than -2, but I picked -1. Sorry, I was misinterpreting. Okay, -1 is here, right?
Oh,
So it's to the
okay,
right
yeah,
of -2. Yeah, I got confused. Sorry. So that means -1, -3 is somewhere over here. Then from there, actually, you already know how to draw the graph. You just have to connect this curve with that point and go all the way down. But wait, it will intersect the x-axis, right? X-intercept. But where does it intersect? We don't know, right? So that's why we should work it out first. So sub y equal to 0 to find x-intercept. Then what do we get? We get 0 equals to, I'll just use the simplified version, the one where the x minus 2 cancel away. You get 2x minus 1 over x plus 2. From there, it's just simply 2x minus 1 equals to 0 times x plus 2. Right, if you cross multiply, which essentially means the numerator equals to 0. That's what the video mentioned. Right, just equate the numerator to 0. Then you get x equal to half. So that means that you have to pass through a half, 0. Then you just have to connect the dots. So let me just erase this blue black curve and just draw in the curve like this. But you need to make sure that you approach the asymptotes. So over here and over there, you're approaching it. Is that okay? Okay, very good. Then likewise for the other half, you can just sub in x equals to something smaller than -2. In this case, x equals to, let's say, -3. Then y equals to what? 2 times -3 minus 1 over -3 plus 1. What do you get? -6 minus 1. That's a -7. Over -3 plus 1, that's a -2. Positive 3.5. Positive 3.5. Here is y equals to 2. So is it above or below the line?
above.
Above, right? So somewhere here. Then it means you can see already. If you want to approach this vertical asymptote and this horizontal asymptote, and you must pass through that point, it can only be this possible curve. Is that clear to you?
Okay.
Yeah, so then we are done. Okay, so here's a shortcut. You don't need to think about this infinity ideal. You just need to memorize this ideal. Whenever you have a improper fraction, you do long division already, you will get a quotient plus the remainder over the divisor. This fella here will always be an asymptote. The quotient will always be an asymptote. Then it will be it's either two types. This will either be y equals to a constant, so what we call a horizontal asymptote, left, right. Or it could be y equals to mx plus c format. Then this will be a oblique asymptote. It can get worse and become a quadratic asymptote, but honestly, in the A levels, that is not going to be discussed. So I don't think you need to know that. But they showed the video showed you an example. Okay, so the strategy is very simple. So step 1, long division. You get quotient plus the remainder over the divisor. This fella here will be your asymptote, either horizontal or oblique. Oblique means slanted, sorry. Y equal mx plus c. Horizontal means y equals to some constant. Then after that, you draw in the asymptote using broken lines. Then the next step is step 2. Equate denominator here to 0 and solve. Solve for x. So for example, in this case, we got x equals to -2, right? Then this will become your vertical asymptote. This will become your vertical asymptote. Once you have drawn in your, let's say, horizontal asymptote and vertical asymptote, right? You just need to plot points to figure out where the graph will be. Because in order to approach asymptotes, right, you only have a few possibilities. You approach this way, upwards or downwards. You approach this way, from above or from below. Then all you need to do is to plot one point, just like what I demonstrated just now. When x equals -3, you get y equals 3.5, plot a point there. You don't even need to know this limit idea. You just need to know that you want to draw a curve that passes through that point and it will eventually reach the asymptotes. Let me start again with this one. If you pass through this point and you have these two as asymptotes, you need to approach it. Can you have a graph that looks like this? Can or not? Is this possible?
No.
Going towards asymptote here, that's okay. But this part here, is it approaching the asymptote? Then you suddenly make a U-turn and go back. No such thing. Why? Because it fails the vertical line test. One x value gives you two different y values, not a function. Then usually, no, not usually, always, there is only one approach. Like this. Can you see that? There's only one way. Okay, good. So you don't need to know the even and odd idea. Just plot a point. Step 1, long division. You get the quotient, that's your asymptote, draw it in. Step 2, you have the fraction. You look at the denominator, or in fact, you don't even need long division for this step 2. You can just look at the original denominator, like x squared minus 4, x squared minus 4, assuming that there are no holes, assuming we don't have holes. I better write this down. Assume no holes. Then you just take the denominator, equate to 0, solve for x, you get vertical asymptote. So just like this example, horizontal and vertical asymptote. Then you just have to plot. Okay, maybe I should write down step 3. Plot strategic points. Then sketch. Sketch the curve. It must pass through those points, pass through the points, and it must also approach asymptote. This will usually result in only one unique possible curve. So what do I mean by strategic? I mean strategic as in reference to the vertical asymptotes. So for example, we have vertical asymptote here, x equals -2. So you pick a point to the left of it and to the right of it. Because the vertical asymptote splits the graph into the left half and the right half. Here I pick x equals to -3. There I pick x equals -1. Does that make sense? So you use the vertical asymptotes as a guide to figure out what are the x values to choose. And you sub in, get the corresponding y value. I think what the video did was they drew a number line like this, then they have -2, then they pick a value, say x equals -3 here, then they draw it, write down the corresponding y value, 3.5. And then here you pick a value that's slightly bigger than -2, it's -1, get the corresponding y value, -3. Okay, that's just plotting points. Oh. Okay. So let's see another example. Let's say we try. What's a good example? Let me see.
What's multiplicity?
Oh, multiplicity means the power of the x. So for example, if you're solving an equation like x minus 1 to the power of 3 equals 0, we say that you take a cube. We say that this has a multiplicity. We say that, okay, let's just solve this first. How do you solve it? You get x minus 1 equals cube root of 3, cube root of 0. Right? Then after that, x equals to 1 plus cube root of 0. So we say, okay, cube root of 0 is just 0. We just simplify it down. So we say that this happens twice, 3 times. Why? Because you could reinterpret it instead of taking cube root, you could reinterpret it this way. X minus 1 power 3 means just x minus 1 times x minus 1 times x minus 1. Then you have factor times factor times factor equal to 0, means what? Each factor equal to 0, right? And then you connect them with an OR, logical OR, not AND. Then from there, you solve for x, you get x equal to 1 3 times. So we say that it has a multiplicity of 3.
Does it have to be the same how do you say?
Essentially 3 is like the power here. I think that's what the video meant. It's just the power lah. Don't need to think so hard.
Okay.
You'll learn more about this in if you take linear algebra 2, when you start learning about vector spaces and all sorts of fun stuff. Uni stuff. I only learned it in uni. Algebraic multiplicity and geometric multiplicity. You can go and Google. I don't know if you have the prerequisite knowledge to learn it, but okay. I learned this in year 1, semester 2 of uni. I didn't know about this in A levels. So you don't really need this idea. You really don't need this idea to draw the graph. Okay, let me just do one more example. Let's say we try this one, x cubed minus 1 over x squared minus 9. I'll do it using my approach. Okay, so first thing is
long div.
Yes, long division. This is example number 5. Okay, so I'm gonna look at label 5. Y equal this guy. So yes, straight away I see that there's a power 3, power 2, so there's a improper fraction. Then I will just do long division. Long div. So let's write that down. X cubed. I like to write down the blank spaces 0x squared, 0x, then minus 1. Then after that, x squared minus 9. I make sure my highest power on the left side. So x cubed divided by x squared, what do you get? Positive x. You get x cubed minus 9x. I like to write it in the correct column, so it's easier on my brain. You see, x cubed minus x cubed, nothing. 0x squared minus nothing, 0x squared. Okay, I don't need to write it. Okay, don't need to write it. Okay, if it's a 0, just don't write it. Then plus 0x minus away negative 9x, get positive 9x. Bring down the negative 1. Here is x squared. If you try to take 9x divided by x squared, you end up with 9 over x. 9 over x, which is not a polynomial anymore. There's essentially 9x power negative 1. When you have negative powers, it's not a polynomial, we don't deal with that here. So we leave it alone and stop. This is our remainder. Therefore, this is equal to quotient x plus the remainder 9x minus 1 over the divisor x squared minus 9. Okay so far?
Okay.
This is actually the same as 1x plus 0. So this is what we call the optic asymptote.
Okay.
And this one, I can factor out the denominator. I get x plus 3x minus 3. Then from there, I take my denominator, I equate to 0. So x plus 3. So each of the factor will be equal to 0. Solving, I get x equal to minus 3, x equal to positive 3. Now I have all my asymptotes already. These are the vertical asymptotes. Asymptotes means that the graph will approach it. Sometimes it may intersect the asymptotes at small values, but that is quite rare. Then that's why I think the video mentioned that you want to take the function and you equate it to the asymptote. Definitely not the vertical asymptote, but the horizontal asymptote, in this case, the x. And then sometimes you have a solution. There may be an intersection. But let's just assume there isn't to keep things simple. Then here is how you draw the graph. First, you draw in the oblique asymptote, y equals to mx plus c. In this case, it's 1x. So just gonna draw it. Then we have x equals to 3. So we draw in. X equals negative 3, draw in. I need a bit more space. Okay, I probably need to make the y-axis a bit longer. Okay, good. Then now you just need to plot points. Now see, you have asymptotes like this, right? Let's split it up into 3 separate regions. Can you see that there's the left half, then there's the middle, and then there's the right half? Can you see these 3 separate regions because of the vertical asymptotes? Then what you want to do is to realize that, let's focus on the left half. You have vertical asymptote and this oblique asymptote. There's only 2 possible curves that can go. Can you try drawing it? What are the 2 possible curves? Let's say you manage to plot a point and it happens to be here. Then how? Yes, what's the other possibility? Let's say you plot a point and it happens to pass through this bottom. Maybe I should make it a bit more closer to the x. Yes, exactly. So only 2 possibilities. How do you tell them apart? Just pick a point.
Plot point.
Plot point now. So let's say we pick x equals to slightly smaller than -3. But think carefully, -4. Right? -4 smaller than -3, yes? Yes, then you see what's the corresponding y value. Let's calculate off. So I just go for the original version. -4 power 3 minus 1 over -4 power 2 minus 9. Type in the calculator, what do I get? Let me just, I won't show you, I'm just gonna type it on my calculator in real life. Is it positive or negative?
Negative.
Okay.
Wait, positive.
-65 was positive. Wait.
Oh yeah, it's negative.
Negative, right? But negative not enough to tell you apart, because this time, right, if you see how to distinguish between whether you have a curve above or a curve below like this, it's with respect to this vertical, this slanted line. Okay.
Yeah, so it could
when
be here.
Okay, so let's just think carefully. When x equals -4, what's the corresponding y coordinate of this oblique asymptote? Lucky for us, it's just a y equal x, so it's just -4, -4. Then -65 over 7, I see the decimal. It's around -9.285.7.
So it's below.
So it is below. So that means that it must
it's like
be
this.
a point here.
Oops.
Yeah, then you just have to have 2 curves. You just ignore the point, Just ignore the point, plot it later, because it's not drawn to scale. You just have to approach it like this, almost vertical, almost slanted, almost parallel, sorry. And then you just curve slightly away from it. And then at some point, there will be a maximum point, and then it drops down. How to find maximum point? How to find maximum point? Testa, differentiate equals 0 of x. Wow, very long window. I need to use quotient rule. Do you want to find it?
Like you use this, right? Or what?
Yeah, yes, you can use either form. You can also differentiate this whole. Yeah, it doesn't matter because they are equal. Okay. Assume that this graph has no holes. Okay. Then of course you do the same. Yeah. Should we just do it?
Then you, I feel like I can.
You can find it, right? Okay. All you need to do is remember. Yeah, definitely cannot. Just have to differentiate this function, get dy dx equals to, I don't know, happy face. Okay, and then you equate it to 0. Then from there you solve for x. There will be more than one solution to x. Why? Because let's continue drawing the graph. Here it's between -3 to +3. So I'm just gonna pick the easiest point ever, easiest x value ever, which is 0. Aha, easy. Why? It's just 0 power 3 minus 1 over, let me show the function, 0 square minus 9. Then you get -1 over -9, +1 over 9. So 0, 1 over 9 is over here, right? Then you want to approach the graph. There's only 2 possibilities, right? It's either approach this way, almost parallel, and then you curve like this, or you curve that way. But we already figured out it passes through a point there, 0, 1 over 9, definitely above this y coordinate, because y equals x. When x equals 0, y equals 0. So it's above. Then that means our curve must look something like this. But here, I'm making a mistake. What mistake? I'm assuming that my minimum point is at this point itself. That's not always true. The graph could actually be, if I just make my asymptote a bit high, my intersection a bit point, it could be like this. a bit slanted. It could also be
okay.
the other way around. You don't know for sure. So how do you decide? You need to differentiate equals 0, solve for x, get the x coordinate of the minimum point, and then find the corresponding y value, plot the point. It will be either to the left side or to the right side. I don't know for now. I literally don't know until I differentiate equals 0, solve for x. Okay? So let's just pretend it's this way. Let's just pretend it's this way. Probably wrong. Now we go on to the next piece. X equals to more than 3. So let's pick a value bigger than 3. That's 4. Then y equals to what? 4 power 3 minus 1 over 4 square minus 9. Let's calculate this. I think it's positive. Okay, wait, no, not enough. I need the exact value. This is positive 9. Interesting. So let's plot a point. If this is 4, this point here will be 4, 4, right, on the asymptote. So 4, 9 this time. Would it be above or below the 4, 4?
It'll be above.
Above. Then that means the curve must look like. Can you try drawing?
It will look like this.
Very good. Exactly. That's it. Yay, graph sketching completed. You have completed the chapter already. That's all. The only thing about odd or even. Okay, if you really want the odd or even. X plus 3 is to the power of 1. 1 is an odd number. So at x equals to, this was x equals to -3. At this guy, we will have the asymptotes approaching in different directions. How about this other one? And x equals to 3. It's the same direction. Oh, something suspicious going on. This is power 1. I have odd power. I should be going in different direction when it's x equals to 3, the asymptote. Did I calculate wrongly? No, never calculate wrongly. You know what? The simplest way is to just use graphing software. Because for A levels, right, you have access to a GC. You can use a graphing calculator. Here I'm just using the more powerful internet version. Just type in the function. X cubed minus 1 over x squared minus 9. X cubed minus 1 over x squared minus 9, right? Don't tell me I did my long division wrongly. Let me hide it off. What about x plus 9x minus 1 over x squared minus 9? Oh, it's still the same curve. Let me think. Oh, okay. I see. I made a mistake. This is how the graph actually looks. Can you see? Oh, not that simple. This one. Let me try and make it look a little bit nicer. Let's say I go until -20 to +20. It actually looks like this. I see. Okay. Oh, not that simple. Sorry, I didn't think about it. There's another possibility for the curve. Right, of course, yes. Sorry, I made a mistake with this part. I assumed that it will only curve this way or this way, but actually it could curve this way or this way. Because you just need to approach the vertical asymptote. And for this oblique asymptote, for small values of x, it is possible that it can still intersect the asymptote. I assume that it doesn't, but actually it does. Okay, does that make sense?
Okay.
The curve actually does intersect somewhere here. We can calculate that by equating the two by equating the y equals to x with the original function, x cubed minus 1 over x squared minus 9. This guy is the oblique asymptote. This guy is the original graph itself. So we just equate them. So x cubed minus 1 over x squared minus 9 equals to x. Then from here, let's see how do we solve this. X cubed minus 1 equals to x times x squared minus 9. I can factorize this. This is x minus, oh, maybe I should expand the whole thing out. This becomes x cubed minus 9x. This becomes x cubed minus 1. Just nice, both sides got x cubed, don't need to work so hard. Minus 1 equals to negative 9x. Therefore, x equals to positive 1 over 9. Which means the corresponding y value, if you sub in into 1 or 2, you get 1 over 9. This is the point of intersection between the original graph and the oblique asymptote. They intersect at this point. Is that clear?
Okay.
So go back to the graph now. I need to plot a point. 1 over 9, comma 1 over 9. So it must be somewhere on the asymptote itself. Maybe I'll use red pen. Okay, just to clarify again, just now I assumed that even though we've got this point already, I assume straight away that it will be a curve that looks like this or like this. When in actual fact, it could also be the following curve, this one. It approaches the two vertical asymptotes. It also passes through these 2 points. And this particular point here is a point which is on the asymptote itself, the oblique asymptote. So for small values of x, in this case, x equals 1 over 9, it is possible that the graph still intersects the asymptote. Okay?
Okay.
Yeah. Then what's a faster way to determine, to make sure, to catch my careless mistake just now? Use the multiplicity idea. At x equals to positive 3, which came from here, this has a positive power 1. Odd power tells you that. What does it tell you? At the vertical asymptote x equals to 3, what happens?
Odd, different.
Yeah,
different ways
x
to
equal to 3
approach.
in 2 different ways. Yes, one goes towards positive infinity, the other one goes towards negative infinity. So just now my graph, did it have that behavior? No. Just now I drew this and this. Both goes towards the same direction. That only happens when you have even power. But here it's actually odd. So that's why my graph is wrong. So maybe you still actually need that odd and even idea. But actually, you could also prevent that by plotting more points. Plotting more points. If you can plot a few points, then you can eventually see that it will be this curve. Okay? Perfect techniques. Yeah, good. Okay, let's see what else. And behavior holds multiplicity. You watch number 4. What's number 4? Let's see.
It's just the ellipse and hyperbola.
Right. Is that okay? Can Okay, good. So
yeah.
I just want to tell you this thing. The three shapes: circle, ellipse, and hyperbola. Did I miss out anything? Okay, there's parabola. Parabola is just y equal x squared. Y equal x squared is boring. This one secondary school students learn already. You know how to draw this. I just complete the square, get a turning point. X equals to negative b over 2a. Or you take root number 1, plus the root number 2. You divide by 2, take the average. That's the line of symmetry. Line of symmetry. That's also under conical sections, but we just focus on the three that you have already learned from the videos. So circle, ellipse, and hyperbola, I need to tell you how to quickly identify whether you have a circle, ellipse, or hyperbola. You look at the x square, you look at the y square term. In particular, you look at the sine of x square and y square. So if both are positive, and then now you look at the magnitude of the coefficient of x square versus y square, and it's the same. So for example, x square plus 2x plus y square minus 3y plus 8 equals 0. Is this a circle, ellipse, or hyperbola?
Circle.
Circle. Why? Because you got positive 1x square, positive 1y square. Both coefficients, both the sign of the, coefficient of, both the sign of the coefficient of x square and y square is positive and positive. And the magnitude is 1 and 1 is the same. Now for ellipse, it's also plus and plus. Okay, plus and plus. But it's different for the magnitude. So for example, I just need to change that plus 1y square into plus 2y square. Maybe I'll change the x instead. I'll change it to plus 2 into 2x square plus 2x. Then this will be an ellipse. Is that okay?
Mm-hmm.
And then finally for hyperbola, it's just 1 plus and 1 minus, or minus and a plus. Opposite sign. Then the magnitude doesn't matter. The magnitude just affects different things. Should I give an example for each?
Sure.
Okay, let's say we have 2x squared plus, let's not make my life too difficult, 10x, and then plus, oh, I should make it a different sign, minus y squared minus 8y equals to 5. Okay, I think I already made my life quite difficult. Let's just look at example 1, 2, and 3 and draw it. So let's copy down number 1. Equation of circle, you already know the procedure. It's from Amex. You just need to complete the square, right? X squared plus 2x, I think what you usually do is you add on half the coefficient of 2, which is 1 square, and then you add on the right side as well, right? Plus 1 square.
Mm-hmm.
Then plus y square minus 3y. Then you add on half the coefficient. So you add 1.5. 3 over 2 is 1.5 square and 1.5 square. But don't forget that there was a plus 8. Okay, then these first 3 becomes x plus 1 bracket square. The next 3 becomes x minus 1.5 bracket square plus 8 equals to all this. I don't know. I need a calculator for this. I get a 13 over 4. I'll just skip a step. Plus 8 bring over becomes a minus 8. 13 over 4 minus 8. Oh, badly designed question. Sorry, this function doesn't exist. Can I just make this number smaller and change it to a plus 1?
Mm-hmm.
If not, the graph doesn't exist. Okay, then minus 1. 13 over 4 minus 1. Then I get 9 over 4. Oh, it's 3 over 2 bracket square. Okay, good. Then that means that you have a circle. Where's the center? What's the coordinates of the center? -1, 1.5. I realized I made a mistake here. It should be a y. Oops. Is that okay so far?
Mm-hmm.
And the radius equals what?
3 over 2.
3 over 2. Then you just draw the circle. Okay, so plot point. I'll just draw a circle. Plot the center. -1, 1.5. Then if this is radius 3 over 2, that will be 1.5. This is -1. 1.5 will hit positive 0.5. So y-axis is somewhere here. Then where's my x-axis? X 1.5 radius. So it's somewhere here. Is that correct? Should be, hopefully. The radius is 1.5. 1.5 radius, 1.5 radius. This is -1, so it's 1 unit. And then this part is 0.5 units until you hit this point. Can? Circle? Coincidentally, it hits the y-axis exactly. Okay so far? Circle? Very good. Then just label the equation. But next, more interesting one is ellipse. Here is how I will do it. Actually, let me just double confirm whether this function works out first. Give me a second. 2x, because I'm just coming up with this example on the spot. Oh, it doesn't. Good. Okay, let me just change this into a +1 instead of +8. Constant too big, the function doesn't exist. Okay, let's deal with this function. So what I want to do is to first bring all the constants to the right side. So 2x squared plus 2x plus y squared minus 3y equals to +1, bring over, get -1. Then this part you complete the square. So how? I like to keep my coefficient of x squared 1, so it's easier for me. So I end up with x squared plus x. Then from here I continue completing the square, I get x squared plus x. I'll just add half the coefficient of x, which is half bracket square, minus away half bracket square. Okay. Then from here, this becomes x plus half bracket square times the 2 in front. Is it okay so far? Then I do the same thing for my y now. So plus y squared minus 3 over y. So I get y squared minus 3y plus half the coefficient of 3 bracket square minus half the coefficient of 3 bracket square equals -1. This first 3 terms now becomes, oh, sorry, I made a mistake. Here, minus, I forgot to distribute. Only these first 3 can be factored into this guy. Then there's a minus half square. I'm still not done yet. Whoops. Minus half square is -1/4. Distribute the 2, I get 2 times x plus half bracket square minus 2 over 4, which is half. Plus this guy, first 3 terms becomes y minus 3 over 2 bracket square minus away 3 over 2 bracket square. I can evaluate it. Let's just write it as 9 over 4. We got -1. This part is easier because the coefficient of y is a 1. So I don't need to factor out the coefficient first. Right here for the front part, I had to factor out the coefficient 2. Then later on, I need to multiply it back in, which makes my life a little bit more difficult. This part I'll just simplify into 1 over 2. Is that okay? 2 times -1 over 4 gives you -1 over 2. Okay, good. Then plus the rest. Okay, then you have to bring all the constants over to one side. So -1/2 bring over become a +1/2. -9 over 4 bring over, it becomes a +9 over 4. Let's just simplify in a calculator first. -1 plus 1/2 plus 9 over 4. You end up with a 7 over 4. Okay, good. That's not enough. Because I like to do it in a standard form, which means that I want my right hand side to be a 1. Very good. So now I need a 1. How do I go from 7 over 4 to 1? I times 4 over 7. Right? So if I times 4 over 7, that means that this 2 here, I also need to times 4 over 7. I also need to times 4 over 7. Is that okay? Good. Now you need to manipulate it so that it becomes y minus 3 over 2 bracket square on top. Coefficient here is 1. Then divide by 7 over 4. Can you see that?
Yeah.
This other guy, 2 times, okay, I'll just simplify this part here. 2 times 4 over 7 becomes 8 over 7. Then after that, I'll just put it at the side, 8 over 7. Wait. I'll copy this. I'll simplify it to 8 over 7 times the x plus half bracket square. Then from there, last step is x plus half bracket square. I make sure the coefficient in front is a 1. Then I divide by 7 over 8. Is that okay? Okay, good. So now, not enough. 7 over 8 means that, okay, let me double check this. This is, you need to take a square root. Yeah, So it's not enough because you still need to rewrite this as square root and then square. Square root and then square. I'll just remove the brackets. Now we have the final form. This square root 7/8 will be the x radius. This square root 7/4 will be the y radius. Okay, I'll just draw a line like this to remind myself. Then how do I draw the graph? First, you must identify the center. The center coordinates x, y. Why is it? Take this guy, equate to 0, solve for x, you get -half. Take that guy, equate to 0, solve for y, you get +3/2. So you end up with a point here, -half, 3/2. Then when I say x radius and y radius, maybe I should write this down. Oops. I mean the distance from the center. So if we look at this guy, the x radius, square root 7/8, it means that from the center, I will have a distance to the left, a distance to the right, which is worth square root 7/8. Let's just type in the calculator. What is square root 7/8? It's around 0.935. Oh, this is square root 7/8. I'll call it x radius. Approximately 0.9354. Y radius instead will be square root of 7/4, which is approximately 1.322. So who is bigger? Y radius or x radius?
Y radius.
Y radius is bigger, right? So that means that your vertical distance here will be longer, while your horizontal distance here will be shorter.
Vertical will be longer.
Is that correct? Did I calculate wrongly? I hope I didn't. Yeah, should be. If you're on an x and y axis where the scale is 1:1. 1 cm to 1 unit on the x, 1 cm to 1 unit on the right, same scale. So we're just gonna arbitrarily, let me see. Okay, wait, I can do the following. I can just copy and paste. Yeah. Then after that, I draw another short length. This. Okay, then I just connect the dots. So it's like a 铜锣烧. You know what? Let's not make it solid. Let's just make this broken lines. Yeah. So there you go. You have these 4 points. It will just be -half, but you add on the x radius, which is square root 7/8, comma 3/2. This other guy will be -half, but you subtract away the square root 7/8, comma 3/2. The y coordinate is the same. And for the top, it will be -half. The x coordinate is the same, but 3/2 you have to add on the y radius, which is 1.32 square root 7/4. And then finally for the bottom is -half, comma, the x coordinate is the same, but the y coordinate is 3/2, subtract away square root 7/4, the y radius. Is that okay? I think the formal name for it is semi-major axis and semi-minor axis, where major is defined to be the longer one. So this case, you don't call it a y radius, you call it a semi-major radius or axis. I can't remember the exact terminology. I just call it the x radius and y radius. Okay? Can or not?
Yep.
Yeah, so let me show you on the graphing calculator. You can actually just draw it. Is it showing? I hope so.
Yeah.
Yeah, so what do you notice? How come it looks so different from my graph? Why is it elongated on the side, left and right, instead of up and down? Why?
Because the scale of the x-axis, y-axis
is different. Okay, it's 0.5, whereas this one is like 10. So you should press the home button, then you will get the same axis. It will reset to the same scale. Can you see that? 0246, 0246. Okay, then this looks correct. I think it should be correct. I can also I can just plug in the exact point, -half, 3/2. Okay, it's in the center here. Then I can add on a little, what was that? Square root 7 over 8. I'll get that point on the right side. It's here. And then you can do the same for all the others. Just change to a minus. And then this one I keep to the same. Change this to a 4, then I change it to a plus sign. Can you see the 4 points?
Mm-hmm.
Yeah. Okay, so that's the circle. That's the ellipse. Okay, good. Ellipse done. Okay, shall I move to hyperbola?
Okay.
Okay, very good. Let's go to hyperbola. Hyperbola. For hyperbola, you do almost the same thing. Let me copy the equation first. Wait, let me double check whether this function even works in the first place. Give me a second. Okay, 2x squared plus a 10x, and then I minus y power 2, and then I minus 8y, and equals to 5. Okay, it works. Good. Okay, let me show you. Oh, maybe I should draw it on separate pages. How should I do that? Okay, now it's a hyperbola. For hyperbola, same procedure, but you need to realize that there's the coefficients that are different sign now. One is plus 2, one is minus. Okay, don't focus on 2. One is plus, one is minus. That's it. Straight away, it will be a hyperbola. So how do we draw a hyperbola? First step is to standardize it. Same thing as ellipse, you need the right-hand side to be equal to 1, and you also need to complete the square on the left side. Complete the square. So let's see, 2x squared plus 10x, I can factor out 2 first, I end up with x squared plus 5x. This other guy, I factor out a negative sign, I get minus y squared plus 8y equals to 5. 2 bracket x squared plus 5x, I'll just complete the square straight away as x plus 5 over 2 bracket square minus away 5 over 2 bracket square. Is that okay?
Mm-hmm.
I add and subtract, but then the first 3 terms factorize into this, then I subtract away 5 over 2 square. Then subtract away this guy, this time it's y plus 8 over 2, which is 4, bracket square, minus away 4 square, equals to 5. Good. Simplify, you expand, you get 2 times x plus 5 over 2 bracket square, minus away 2 times 5 over 2 bracket square, minus away y plus 4 bracket square, plus 4 square equals to 5. Then after that, I bring all my constants to the right-hand side. So let me copy down the non-constants first. These 2 fellows bring over. I end up with 5 plus 2 times 5 over 2 bracket square minus 4 square. Type in the calculator, what do I get? Let's see. 5 plus 2 times 5 over 2 bracket square minus away 4 square. I end up with a 3 over 2. Okay, good. Then let me just copy down everything to make it neat and tidy. Bring it closer. Okay, so far, this completing a square set.
Mm-hmm.
Yes, okay, next. So we're gonna standardize it. We need 1. What do you have to multiply by? 2 over 3. Yeah? So we're gonna multiply by 2 over 3. I'll just show the step. 2 over 3 bracket, copy and paste. Distribute 2 over 3 times in the first guy, you get 4 over 3 times of blah, 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 blah. Then 2 over 3 times negative 1 here, you get negative 2 over 3, blah, 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 blah. Equals to 1. Equals 1 is good. Now this one, not so good. You need to make sure that the coefficient in front of the bracket is 1. So how do you do that? You bring it to the denominator. The constant 4 over 3 becomes a 3 over 4. Can you see that? Here to here?
Mm-hmm.
Can Okay, good. Then minus sign remains outside. Then y plus 4 bracket square. 2 over 3 bring down, it becomes divide by 3 over 2. Right? Not enough. You still need to rewrite as a square root and square, square root and square. And then we have our standard form for the, what do you call it? Hyperbola. Okay, so the trick here is the positive coefficient in front of the letter tells you the shape of the graph. You see plus x, it must become a x shape. But there's a trick, one more trick you should know. There will always be what's known as the oblique asymptotes. Here's a trick I will show you. We go to the, which is the correct form. Okay, I'll just use this form here to find the oblique means slanted asymptote of the graph. Here's a trick. The proper reason requires limits, but I don't want to talk about it. So I'm just going to replace the right-hand side with a 0. Okay? Replace the right-hand side from a 1 to a 0. Previously, it was a 1. It just changed to 0. Okay? Then I try to make y the subject. So let's see what happens. Minus 2/3 I bring over, it becomes positive 2/3 y plus 4 bracket square equals to 4/3 x plus 5 over 2 bracket square. Then from there, I make y the subject. So y plus 4 bracket square equals to, divide by 2/3, I end up with 2. Is that okay? Okay, 2, good. So from there, I want to make y plus 4 the subject. I take a square root. So plus minus square root of 2, square root of a square. I'll just write it down. Ooh, handwriting. Square and square cancel away. You're left with plus minus square root 2 times x plus 5 over 2. Then that's y plus 4. So I skip one more step. Plus 4 bring over, I get negative 4. Is that okay? Can. Then we can simplify a bit more. So this becomes y equals to minus 4 minus square root 2 times this guy. Or y equals to negative 4 plus square root 2 times that guy. Distribute and you get your mx plus c. Those will be your asymptotes. So this is negative root 2x. Negative times positive gives you negative 5 over 2 times root 2 minus 4. This other guy will be y equals to minus 4 plus root 2x plus root 2 times 5 over 2. I'm just going to rewrite this minus 4 on the right side. Okay, so we got our 2 asymptotes already. Can? Yeah. So what you will realize is that these 2 asymptotes are, if you draw it, it will look something like, let me just draw it like this. One will be positive, one will be negative. Okay, and they will intersect at a point here. What is this point? Let's copy down the standard form first. You'll realize that it will pass through. If you take the x plus 5 over 2 here, you equate it to 0. You end up with x. Oh, I better use back my solid line. You end up with x equals to negative 5 over 2, right? Then this other guy, y plus 4, you equate to 0. You end up with y equal to negative 4. This point must be negative 5 over 2, comma, negative 4. This is what we call the center of the hyperbola. So the center of the hyperbola, it's not, the hyperbola doesn't pass through the center. It's just surrounding it. Okay, you can just do simultaneous equation on these two, and then you solve. You will end up with this as a solution. Can? Okay, yeah, good. So it's very similar to the circle and the ellipse idea. You just have a x minus something, then that here is x minus negative 5 over 2. So negative 5 over 2 is your x coordinate of the center. Here is y minus negative 4. So negative 4 is the y coordinate of the center. Here and there. Okay, good. Then now remember the trick. Here is x, there's a plus sign in front of it. So what shape will you have for your hyperbola? What shape?
You'll have an X shape.
And it must pass through the two. Let me try and make it symmetrical first. Sorry, give me a second. Try and make it symmetrical. If not, it's gonna be a very messy. Okay, there should be a sort of rectangle shape going on. You know what? Give me a second. Just draw a rectangle first. Okay, draw a rectangle. Okay, you know what? I'll do this. Let me count. 1, 2, 3, 4. 1, 2, 3, 4. Then I'll duplicate the rectangle. Then I'll just cut across like this, cut across like this. Let me change this into broken lines, and then I can erase my rectangle. Okay, perfect. I have my two perfectly symmetrical diagonals. Okay, then you draw the X. So how? You just have to go like this and like this. Go like this and like this. And there you go, that's a hyperbola. Okay? Okay. That's it. Oh, one more thing. How about the square root 3/4 and the square root, sorry. Is it, yeah, how about the square root 3/4 and the square root 3/2?
How about you?
Ah.
What do you mean?
How do we use that information here?
Oh,
We haven't drawn it yet, right? Where is that information used? Okay, I teach you now. So this guy, because it's an X, right? You only care about the X for now. This guy here, you get something like the X radius. It will be equals to square root 3/4, right? Let me increase the font size. Square root 3/4, right? So if it's, where do you get the square root 3/4 distance? It's actually over here. This distance here, it is, let me zoom in. Square root 3/4. Likewise, for this other distance here, it will also be square root 3 over square root 4. Okay, I just write the whole thing. I know you can simplify this into square root 3/2, but let's just simplify it. Let's not bother with that. Okay, so that means that the two coordinates here will be what? -5/, let me use my black pen. -5/2, -4, but you move root 3/4 units to the left. So you minus away. I'll use my red pen, root 3/4. For the other guy, it will be plus. Instead of a minus, it's a plus because you move towards the right instead. Okay? Then the X and Y axis is actually, you have to use a graphing software to help you, or just plot a few points and realize it's actually here, the origin is here. Is that okay? Hyperbola? Yeah, so the trick is always to draw the asymptotes first. Sorry, no. Is to convert into standard form first. Then after that, you do the trick, replace the right-hand side 1 with a 0, solve for the asymptotes, draw the two asymptotes. Okay, then after that, you draw the graph as the last step. The graph drawing comes as the last step. Everything else, the asymptotes are the standard form, the asymptotes, they come first. Is that clear? I must do the prep work before you draw the actual graph. So let me just show you on the GC, not the GC, I mean Desmos. This is the hyperbola. Can you see the red one?
Yeah.
Okay, very good. Then let's type in whatever we just found in the standard form. It should be correct. I'll just show you. So x plus 5/2 to the close bracket to the power of 2 divided by, this is square root, on the denominator, forgot to press down, square root fraction 3/4. Whoops. And I raise to the power of 2. And then I'll just copy and paste this, but this in between, it's a minus sign. I change this into a y. 4. Okay, need to remove. This is just 4. Then the denominator is 3/2 instead of 3/4. Equals to 1. Notice that the purple graph is exactly the same as the red graph.
Yep.
Okay, because they are equivalent. Good. Then where is -5/2, -4? This is the center. Can you see the center? Okay, good. And then how about this point here? What is this? It is just the center, but you subtract away the x radius. Can you see this square root 3/4? You subtract square root 3/4, you end up with the left point. Then similarly, you can have the other point being plus square root 3/4 on the right side, the black one.
Okay.
Right. And then this is the left. Oh. Is that okay?
Yep.
Then the y, I think that one is not so relevant. Don't worry about it. And if you want to find the x-intercept and y-intercept, all you need to do is to sub x equal to 0, sub y equal to 0. To find the x-intercepts, you substitute y with 0, right? Then you solve for x. Do you want me to show you?
Okay.
Okay. It's very long-winded. Yeah. Then to find the y-intercept, you just sub x equal to 0. Oh, then you just record down. Nah, don't need it. Okay, I'll just do it. Okay. So this is on graphing. Let me find the asymptotes here. Okay, not asymptote, the intercept. Let's find the x-intercept first. So you sub y equals to, oh, I haven't shared screen yet. Oh no. Load. Faster. Okay, done. So this graph still incomplete because we have intercepts here, and here. So let's try to figure out what those points are. So if you want the x-intercept, you're gonna sub y with 0, right? So we're gonna do that. So sub y with 0, what do you get? Which form do you prefer? Do you prefer the cleaned up form or the original form if you want to solve for x?
Original.
Original form, right? You want to deal with fractions, right? Math students are bad at two things, fractions and negative numbers. So you gotta substitute in the one without the fractions. So here, minus y squared minus 8y, that just becomes 0. Minus 0, minus 0. Okay, I'll just erase it. Equals to 5. And as a result, you have a quadratic. And just solve. Yeah, just use calculator. It's just calculator. I'm not gonna try and factorize it myself. I'm just gonna use a calculator. You can use x equal negative b plus minus square root of b squared minus 4ac over 2a, but there's no point. Just use a calculator. Okay, then from there you solve for y. Sub in into y. How do you get y? And you copy the equation first. Okay, it's already there. So you just sub in into the expression here. Then these two values will become a number. You bring. Okay, I'll just show you, at least for one of them. So yeah. So wow, so long-winded. Okay, 0.45803. You can get the exact answer if you want, but I don't think there's any point to doing that. Sorry, no, I have to sub in over here. Then plus 10 times of that x minus y squared minus 8y equals 5. Type this whole thing in a calculator. What do you get? 0.45803. I want this guy 2 times that guy square plus 10 times of that guy. I end up with a 4.9998 minus y squared minus 8y equals to 5 minus y squared minus 8y plus 4.9998 equals to 5. Bring the 5 over, I get negative 0.0002. I'm pretty sure that should be a 0, but it's just rounding error. Then from there you solve. So negative 1, negative 8, negative 0.0002, and I get y equals to negative 0.00025. Y equals negative 7.9999975. Actually, hold on a second. That doesn't make sense. Why? Because we should already know our y value as y equals 0. Oh no. What happened? Why would you have a negative 7.999? I was expecting this answer because it will be approximately 0. But why is there a negative 8? That doesn't make sense. I think if you substitute in over here, you won't get a 5, right? Then this is a rejected answer. But anyways, we don't actually need to calculate the y, sorry. We just need to know that y equals 0. Then we get our two x-intercepts. Is that okay?
Mm-hmm.
X-intercept fine? Good. Okay, this step, sorry, I throw away. Don't need it. How about y-intercepts? You just sub x equals 0. So you just go back to this equation, but you replace the x with 0. So 0 plus 0 minus y squared minus 8y equal to 5. So we get minus y squared minus 8y minus 5 equal to 0. You can times -1 if you want, or just type in a calculator. So -1, -8, and -5, I end up with -0.68337, -7.316. So yeah, that's it. That's my two y-intercepts already. X equals 0, x equals 0. Just make sure you plot it carefully. So what we have is 0, -0.683. I'll just run off the 3SF straight away. 0, -7.32. Let's go to the graph above and plot the points. Let me see. Where should the points be? 0, -0.6 and -7.32. So it should be here. Okay, I realize my graph not so accurate. Maybe you need to go a bit lower. You know what? I should just move my x-axis up. Yeah. Should be somewhere here. Okay. Then I can plot the point here and there. Can you see the 2 points? Is it okay?
Yeah.
Then of course finally and the what do you call it? The x-intercepts. So let me just quickly plot it. So 0.458, 0, as well as -5.46, 0. Okay, good. Copy and paste, then I can bring it up here. So this is how you do it manually. Do you really need to use this skill when you have a GC that can do it instantaneously for you? I don't know. And as a com science major, do you really need to know this?
I don't know.
Maybe you need it for your engineering math course, but after that, not really. Unless you're gonna do game design, and then you'll need to know this to help you. Maybe you're gonna use a parabola or hyperbola to model after the curves of certain scenarios that your game design, some character you're trying to design, or some background image you're trying to create. You may need to know. I'm not sure. Okay, so that's a hyperbola. Okay.
Mm-hmm.
It's very similar for y square. I won't show you it. Okay, you just have to instead draw a y shape instead. The key trick is you look out for the plus sign in front of x squared, then you get x shape. Plus x squared, then your graph will be a asymptote, center here, x shape, approaching the asymptote. Positive for the y square instead, then you have asymptote, center here, but instead of an x, you have a y shape like this. Okay, but this time, previously we found out this distance, right? It's just the x radius, right, from the denominator, right? If you recall, this part square root 3/4 gives you this and this. But for the other case, if it's if it's a positive y square, then it will be using this particular distance. Okay, actually, let's just try for y as well. I'll just show you. Let's say we reverse the question. This is another example bonus. When it's a y, let's just say I change the sign. This one plus sign, this one minus sign. I swap it around. Let's see what happens to the graph this time. I won't give all the details about the x and y intercept. I just want you to know that when you want to find the asymptotes, you do the same thing, right? Right hand side, replace with 0. That means that you end up with this guy equals to 0, but if you try to solve this, you end up with the exact same equation. Do you agree?
Mm-hmm.
Because minus over you get plus on both sides. So I'm just gonna recycle the asymptotes. We end up with the same asymptotes, copy and paste like this. Okay, good. So that means that I'm just gonna recycle my diagram. Everything stays almost exactly the same because the asymptotes are the same. All I need to change is okay, actually a lot of things need to change. How do I erase quickly? I don't know. Do it manually. Okay, erase. that I will need is to draw a Y shape. Is it? Oh, no, the center still stays the same. It's just that this time it's a Y shape. Let me try and extend the length a bit. So we get a Y shape. And the main point I want to bring up here is that this time we have a vertical distance over here and here. Can you see the two vertical distances?
Mm-hmm.
They will be symmetrical and it will just be square root of. This time you don't look under the X anymore. You look under the Y. So let me highlight the Y this time. Oops. Highlight the Y. Then there's a positive sign. So that's why we get a Y shape. We get a Y shape. Can you see that it looks almost like a Y when you have two curves like this? If you write cursive Y, it looks like this. And whoop, whoop, like this. Happy face on top, sad face below. So positive Y, then you get that shape. But anyways, focusing on the denominator, you get square root 3 over 2, not 3 over 4 anymore. Not this one, but this one. Underneath the positive Y. So you get square root 3 over 2. Let me just draw it in. Square root 3 over 2, square root 3 over 2. Oh. Which means that this time, what's the coordinates of the point above here? Can you try? What is it? The center is negative 3 over 2, negative 4. So what's the coordinates above? Which one stays the same, X or Y?
X stays the same.
So it's negative 3 over 2 here, but the Y will be negative 4. But you, what do you do? Add on square root 3 over 2. Okay? How about this other point at the bottom?
-4 minus root 3 over 2.
Very good. Okay, as simple as that. Okay, then the rest, you just fill in the blank on your own. How to find the intercepts? You go and do it yourself. Okay? Is that okay? Can Very good. Okay, what else do I need to cover today? Let me see. Major axis, minor axis, right? Piecewise function, did you go and learn? Optional one. Option A? No, that's not optional. Number 5, number 6. Yes, no?
No.
No, okay. Crash course. I explain. So the idea behind piecewise function is that, let's say you have y equal x. Let's say I make it a bit different. 3x minus 2. What is that? That's just drawing the graph. 3x, but you minus 2. So maybe something like this. I don't know, for example. That's minus 2. Notice that I just straight away draw all the way. That is assuming that my domain is an element of all real numbers. Oh.
Okay.
What happens if I change the domain? X, an element of double vertical line, then R. This is called the set of all real numbers. There are other sets, such as this guy. This is a set of natural numbers. Natural means means the set. It's just a fancy way of saying the set of 1, 2, 3 all the way. Curly brace 1, 2, 3. Yeah. Then there's also C here. This is complex. Got A plus BI. Square root square root -1, and you get I. But I haven't taught you that, so don't worry about it yet. What else? Q. Q and then vertical line. This is called the rational numbers. Basically, you can rewrite it as a fraction. Can write as a fraction. So irrational numbers will be numbers that are outside the rational, such as the opposite would be irrational. Square root 2, pi, and e, for example. You cannot write it as a fraction. Square root, they'll just have decimals of weight. Right, so now, anyways, let's change the domain. So y equal 3x minus 2. Let's say that I introduce this funny thing known as a piecewise function. Y equals to, I draw curly brace like this. Then 3x minus 2, I say it's for, let me look at the graph first. 0. So say x less than 2 over 3. Okay. Then after that, I say x when x is more than equals to 2 over 3. How does that work? That means that you have to copy the exact same graph as before. Sorry, I didn't draw my x and y axis. Let me do that. Okay, but you realize that this point here is 2 over 3, right? Agree or not? This is y equals to 3x minus 2, sub y equal to 0. Yeah, y equals 0, blah, 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 x equals to 2 over 3. But here it says x less than 2 over 3. So that means x is 2 over 3 and all the way towards the left, you just draw the original graph. Let me use my highlighter. Yellow color for this part. But it's strictly less than, so it should actually be an empty circle there, right? Up to this point, it will be an empty circle. Is that okay?
Mm-hmm.
Okay, good. Then next part. This time you have the next piece. This is called a piecewise function. This is piece number 1. That's a piece number 2. Okay, but you follow the domain of the x values. So x more than equals to 2 over 3, right? What does that mean? It means you start from 2 over 3 inclusive of 2 over 3, so have a solid circle. But this time you follow y equal to x. So this is 3x minus 2. Its gradient equals 3. Next, we're going to draw 1x, which is y equal to x. So would it be steeper or less steep?
It will be
One.
steeper.
No, less steep. Okay, yeah, you actually got it correct.
Like
Same gradient. This
yeah,
is steeper. This is less steep.
more rise. Okay, yeah, less steep.
Less steep. Now this is more. Smaller gradient, then smaller, and that's just another way of saying less steep. Okay, so anyways, let me use blue color to describe this. Then I'll just draw the graph in blue. Then I'll end up with this guy. But you only start from x more than equal to 2 over 3. Then it will just be a straight line. But this time, you will shade in the circle blue color because you are now part of this second piece and it includes x equals 2 over 3. The case where x equals 2 over 3, you end up at 0. Oh, sorry, actually not correct, right?
2 over 3, x equal 2 over 3, y equal 2 over 3.
Correct. So my graph is wrong. I should actually float above until I hit this point. I draw the circle, shade in. This is x equals 2 over 3, y equals 2 over 3. And then you have a gradient, y equals x, all the way above. So this is what we call the jump discontinuity. Continuous line means you can draw the line without lifting up the pencil. And UOUS. Draw entire continuous graph or continuous function fx means you can draw the entire y equal fx without lifting up a pencil or pen, whatever you use to draw, right? Here, when we say discontinuous, it means it's the opposite. NUOUS. You cannot draw it with without lifting up the pencil. You see, if you want to draw it from left to right, you draw an empty circle. Then how do you go to the next line without lifting up the pencil? Draw the broken line. Cannot. The broken line is I draw for fun. You have to jump up like a Mario. I imagine you are Mario here. What kind of hat does he wear? Don't know. And you go until here. Then from here, he has to jump up to hit the next platform. Then he can continue moving. So there's a jump discontinuity. Does that make sense?
Mm-hmm.
He has to jump and then he can land on top. So we call this a jump discontinuity. Yeah. Just now, when you are looking at a whole example, right? Let me scroll up. Where was it? Here, this example, the graph is all the way to the left and all the way to the right. Right? The example, the very first example or second example, there was a hole here. This one we call it a point discontinuity. Discontinuous because you cannot draw this entire graph without lifting up the pencil. You cannot. You have to skip the point first, lift up the pencil, then put the pencil at somewhere else, and then continue drawing. But it's only one single point, so we call it a point discontinuity. Mario don't need to jump, just have one single point, so you can walk a larger step and then cross over. Okay. I assume that you've played Mario before. Do you know what I'm talking about?
I think so.
Yeah, Mario, you just walk along the platform like this. Just that it's a slanted platform. You don't get to see that in Mario. But we call this a point discontinuity. Yeah, that's a big one. Is that okay? Yeah, it's just some terminology. Okay, good. Let me think. Yeah, so that's how you draw piecewise function. Follow the domain, then you draw the function. They say x less than 2/3, then you don't go beyond 2/3. Then if it's more than equal to 2/3, you will just continue from more than equals to 2/3. Let me show you how to do it on a GC. On decimals, okay? Then later I show you on GC. So remove all the functions. Okay, so let's draw this. How do you draw it? There's no, I don't know of a piecewise function. I only know how to do it function by function. So let's say we start off with 3x minus 2 like this. Can you see the screen now? Is it showing? Yes, all. Then you have y equal x. Can you see the two graphs? Now they have an extension to the left and to the right, but we don't want that. We just want the red graph, which is the 3x minus 2, to be stopping at x equals 3/2. So here's how we do it. You go, have you tried decimals already?
Yeah.
Yes, please make sure you go and learn this, okay? It's very, very useful. Okay, just press a spacebar to make it look nice, or another spacebar, or many spacebar, doesn't matter. Then you open a curly brace. Okay, it's above the square bracket. It's on the same button as the square bracket, beside P, I think, on laptop keyboards. Then you just type in x. Then you have the arrow on the same button as a comma, less than. Then you type in frac. Frac will introduce a fraction. Then 2 on top, press down, press 3. Alternatively, you can type in 2, then just type a slash. Same button as a question mark beside the shift button. Slash, and then type a 3. What do you see? It just cuts it so that it stops at 2/3. Do you see that? Then likewise for the other guy, there's a few spacebar, doesn't matter how many spacebar you type. X more than, do you know how to get the more than button? It's like the question mark, and then you type equal, it will automatically have a line underneath the more than. Do you see that? Equal, backspace, no more equal. Equal, backspace, no more equal. More than equals to 2/3. Okay, then you get the graph like this. It has a jump discontinuity. Can you see the jump? Here to here. Can so that's how you draw it using decimals. Let me show you using a GC now. Give me a second to load up my GC. Okay, still not there yet. Here. Is it showing?
Yeah.
Can So what you do is you press y equals y1. Then you wanna do it along with me, or I just do it?
You just do it. Nice.
Just do it. Okay, you can watch the video later. So you go to math. You scroll down and up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just go up. Then you eventually hit to B, piecewise. Then you press enter. They'll ask you how many pieces. Here we have 2 pieces. So you just press left and right. The double arrow there means left and right. Just select 2 pieces. Go to OK, press enter, you get 2 pieces. Then you just fill in piece by piece. First piece is 3x. It's over here, this button beside the alpha. X minus 2. Then you go to the right. What is it? X less than 2/3. Right? So you type in the x again. Less than symbol. Oh no, where's my less than symbol? You have to look at this. Can you see a blue color TST test button?
Yeah.
Press second test. Then there will be test, there's logic, there's conditions. Let's not go to conditions. Let's just focus on the simplest test and just look for your inequality. X less than, so number 5. You can just press number 5. I'll just scroll down and press enter. Less than what? 2/3, right? So you can type 2 divided by 3. But that's a bit confusing. So let's go, let's delete, and delete the values. I think it's very obvious. Hopefully, you want a fraction to make it look nicer. How do you do that? Press alpha. Okay, press alpha first. Then after that, you see all these green color F1, F2, F3, F4, F5. When you press the green color alpha button, it will activate all the green buttons. So let's click on F1. What do you see? 1, 2, 3, and 4. This first option, N/D, has a box/box. select the first option, or just scroll up and down until you hit the first option, or press number 1, press enter. Oh, you get a fraction. Is it intuitive? Hopefully. Press 2, then you press down, and then press 3. Then now you go down, press left. Okay, we want the next function x, right? So type in x. Next one is x more than equal to over 3. So you just do the same thing. Press the variable button here. Then second test more than or equals, which one is it? Number 4, then press enter. You want a fraction, alpha f1, go for number 1, type in 2, go down, you get 3. And now you just press the graph button. Oh, whoops. Please ignore that bell curve. Okay, hold on. It's not drawing because it's taking too long. So I can press the enter button. It will turn into white color. It will pause the button. It will pause the graphing. If I press enter again, it will turn into a yellow. Look at the top right corner. It will continue loading. But the scale is wrong, so I can't see anything. So let me try again. Let me type in 1, press graph. Oh no, it's loading very slowly. Press on to terminate. When you press on the button, the loading button at the top right corner disappears. It will stop the graph. Then I can go to window. No, not window. Maybe I'll just zoom first, then click on number 6Z standard. This will give you a standard curve. Let's see what happens. Now you can see the graph. Can you see it?
Okay.
Can all? Good. So that's it. That's the graph. Okay, why is it? I have a y equal 1. I clear this. I don't want y equal 1. I can draw. Or if you find it too slow, right, you can go for a lower quality one by, we just stop it. I press on, I terminate it. If I press graph again, it will load again. Restart from the beginning, very slow. But if you want to make it go faster, here's how you can do it. Click on window, go down until you hit the X resolution. I'm also not too sure what it means. How come higher value will give you lower resolution? But go for number 8. When X res is 8, let's take a look at how fast it graphs. Whoa, so fast, but very choppy. It's not as precise. If you click on trace, press left and right, you can trace along the graph. But you see that it jumps quite a lot, right? You see that? 8.8, then 6.9, then 5.7. It's jumping by 2 values each time. So the quality will be lower, but at least it graphs faster. In case you need to know that. If you want, you can always change it back to number 1, and then you graph, and it will be very precise. And it loads extremely slowly. But it becomes more precise because you can see there's a gap there. You see, previous one they didn't have a gap, which is a wrong graph technically. And if you press trace, you'll see that it goes very, very precisely. 1.06, 1.21, 1.36. So it's jumping by decimals of 0.2, 0.2. Okay. If you find this too small, you can also zoom in. You can click number 1 zoom box, then go to the top left corner, press enter, then stretch the box towards the right and stretch it down. You'll open up a net, a sort of box. So what do you think happens if I press enter now? You just zoom in to that box. So you just draw a very nice graph for you. Okay, but you zoom in. Okay, that's zoom box. Okay. Very good. You can press trace now, then you can find the different values of this point. So it's very, very slow. Very, very slow. Okay, I will use decimals if I can. Okay, piecewise function.
Yeah.
Right. If you wait, one more thing. Let's say that you let me just unclick this equal button. Then let's say that you're using the traditional calculators, older version of calculators. This 3x minus this piecewise function, which you activate from math and then you scroll up to number option B. This will not be available in older calculators, but you can still draw graphic piecewise functions. So in case you're using an older one, let me show you how to do it. You type in 3x minus 2, you want only x less than 2 over 3. What you do is you press, if I am not mistaken, you press the slash button, which is the divide button. Then you open curly brace, and then you type in the same thing, x less than 2 over 3. So x, go to second test, scroll down to less than, then 2 alpha f1 fraction 3. If you don't like the fancy fraction, you can always open up a bracket, 2 divided by 3, close the bracket. Then close the curly brace, second brace here. Can you see the brace over here?
Yeah.
The blue color one. Okay, good. Okay. Then maybe I'll just make things simpler by deleting this. Okay, how do I delete? Okay. So we have a y2. And then the other function was an x, right? So you just draw x, and then you put a slash button, then you open a curly brace, introduce a variable x more than equal to over 3x. So second test, go to more than equals, that's number 4. 2 over 3 is 2 divided by 3. Okay, this one the calculator can understand. So I can get away with not putting in bracket. Then this is the traditional way of typing piecewise functions. Draw the graph, you get the same thing, if I am not mistaken. Okay, you get the same thing. Is that okay? The new version TI-84 plus CE, it will give you the piecewise option under math. Like math, then you scroll up to piecewise option B. But in the older version of the calculators, you gotta do it piece by piece like this. 3x minus 2, then put a divide symbol. The slash there means divide. Open a curly brace, then you put in the condition. X less than 2 over 3. Likewise for the other guy, slash, open curly brace, x more than equals 2 over 3. Okay? 可以吗? Understand now? Okay, very good. What else do I need to tell you? Let me think. Let me share my screen first. That's for limits. Oh, right, limits. Just crash course idea on limits. So okay, if you look at this guy, there's a jump discontinuity, right? So how we describe it is the limit of y as x approaches 2 over 3 d and e. What do you think is d and e?
To not
Does not exist. Okay, does not exist.
okay.
What do I mean by does not exist? It means that if I approach it from the left, you see, I start with values that are slightly 2 over 3 is approximately 0.66666. So let's say we start with 0.660. Then I sub in x equals 0.660. I get a y value. I sub in with 0.661, 0.662, 0.663. I get different values. Eventually it will hit 0. But I cannot sub in, okay, eventually it gets very, very close to 0. But if I go from the right instead, I sub in with values which are bigger than 2 over 3. Let's say I have x equals to 5. What's my y value? Which function do I use?
You use the
bottom
bottom function, y equal 5.
Why then? Because x equal to 5, which condition does it satisfy?
Second one.
This is else. If x is less than 2 over 3, this one is else. X more than equal to 2 over 3. Have you done programming already?
A bit
of coding. So you must know how to type if else condition already. This is if x less than 2 over 3, and this is else x is more than equal to 2 over 3. So 5 satisfies the second condition, so you end up with a x value. Okay, so y equal to 5. You wanna do some Python programming? You want me to show you how to type up this function in Python?
okay.
Just for fun. Okay, let me load up my Spyro. Oh, it's gonna wait. Well, it's gonna take 1 minute to load. Maybe I'll talk about something else first. So that's jump discontinuity. The limit doesn't exist. The key condition you need to remember is a flow chart to check whether a limit can exist or not. First, you need to check the left hand limit equals to something. Next, you need to check the right hand limit equals to something, a number. Then number 3, you have to check that the left hand limit is exactly equals to the right hand limit. If then you conclude that the full limit exists. So what is left hand limit? What is right hand limit? Yeah, I better write this down in case you forget. Left hand, right hand. Basically, you look at the graph. So in this case, the left hand limit, what is it equal to? Here's how you write it. So the notation goes like this. Number 1, left hand limit is lim of the y. In this case, whatever is the function. Let's just call this f of x. So we make it more conventional. Instead of lim of y, we say lim of f of x. You take the x as it approaches 2 over 3, but you put a small little minus sign at the top right corner. Do you see that? 2 over 3 with a minus at the top right corner? Can or not? Is that okay?
Yeah.
Yeah, so that is describing, okay, so that is describing the left-hand limit, meaning that you approach this x equal to 2 over 3 from the left. The minus sign means you put in values of x which are always slightly smaller. Minus sign means smaller than 2 over 3. And you realize that the limit is what? It's the y value which the graph is approaching from the left. Can you tell me what's the limit here as you approach from the left? What is the y eventual y coordinate when x equals to 2 over 3, but you go from the left? 0, right? You ignore the right graph. So it's just 0. How about the right-hand limit this time? Same notation, but just change the minus sign to a plus. So x approach 2 over 3, but from the right. Means you always sub in values of x which are slightly bigger than 2 over 3 into the f of x. What is this equal to? You approach from the right.
2 over 3.
You look at the y coordinate, okay, 2 over 3. So it's equals 2 over 3. Then step number 3 is to check whether the limit, whether left-hand limit equals to right-hand limit. Clearly, the limit as x approaches 2 over 3 from the left minus of f of x equals to 0. 0 is not equals to 2 over 3, where 2 over 3 equals to the limit of f of x as x approaches 2 over 3 from the right. Since they are not equal, therefore we conclude that what we call the full limit as x approaches 2 over 3 itself, f of x, does not exist. Is that okay?
Mm-hmm.
Let's talk about another idea. So let's copy down this procedure about calculating limits. Now I'm discussing about calculating limits already. Calculating limits. The next idea we're going to discuss is, let's say we have a graph that looks like x plus 1, but you multiply it by x minus 5 over x minus 5. How does this graph look? It must just be x plus 1. Okay, let's say is x an element of all real numbers, slash curly brace. I put in a 5 here, I close the curly brace. What does this mean? This is referring to the set of all real numbers, but you minus away 5. You remove 5. So this means that I will have a graph that looks something like this. I hope you can see that these two can cancel away, right? X minus 5.
Yeah.
But I purposely introduce it. Why? What will happen? When you have denominator, what must you always do? Set denominator equals to 0. Not cancel yet. Equal to 0. Or not equal to 0. Because you cannot divide by 0. Bring it over, you get x not equal to 5. So what do we get? A problem. We get a problem. It could be a vertical asymptote, or it could be, in this case, if they can cancel away. What do you call this? Hole. Right, there'll be a hole in the graph. Is that okay? So that means that if this is x equals to 5 here, the remaining function, if after you cancel off the x minus 5, is x plus 1. So you sub in into the resulting function x plus 1. When x equals to 5, y equals to 5 plus 1, which is 6. So that means this is 6. There'll be a hole there, right? So what is, let me ask you a question. What is the limit as x approaches 5 of, let's call this y equal f of x? This whole fraction is f of x. What is this equal to? So you must follow the 3-step procedure. First, you need to verify what is your left-hand limit. Step 1. Left-hand limit. How do you write it? Lim fx. Can you fill in for me? How do I get the left-hand limit? You write down on your own.
Wait, what?
Left-hand limit. Okay, I show you the example from before, like this. Wait, left-hand limit, you need R5 with a right corner, minus sign, good. What is this equal to? Equals
6.
to, you must focus on the left half of the graph. Can you see my yellow arrow here? If the value is eventually reaching 6, right? Okay, good. So that means that you end up with just equal to 6 from the graph. Step 2, right hand limit. This time lim fx, but x arrow 5 top right corner is a plus sign. What's this equal to? This time you approach from the
Right hand side.
right hand side. So you go from the right hand side like this. What do you get?
6.
Yes, exactly. It's still 6. So therefore, conclusion is step 3. Since the left hand limit equals to 6, which is equals to the right hand limit, right? You approach from the left, you approach from the right, you get the same y coordinate value 6. Therefore, you conclude that the full limit means just x approach 5 itself. Don't put a plus sign, don't put a minus sign at the top right corner of f of x is equals to 6. Is that clear? So the limit exists. The limit of this fx as x approaches 5 exists. But how about the value? Does f of 5 exist? You did the worksheet already on the function notation. I hope you know what's f of 5. Substitute with 5, right? But you must use the original format of fx. Fx equal to this expression before you cancel. So if you sub in f of 5, what do you get?
Math error.
5 plus 1 times 0 over 0. Very good. You end up with 6 times 0 over 0, which is 0 over 0, and then you get math error. This is what we call an indeterminate form. Now, if you try to evaluate a function like this, sorry, actually not only if you take the limit, then it's indeterminate. Okay? Oh no, sorry. Yeah, it's indeterminate form, correct. Then it's essentially a math error. Right? So the function value, this is what we call the function value, it doesn't exist. DNE. Yet the limit does. Limit value exists. The full limit. In this case, we say that the function is not continuous. When the limit can exist, but the function value does not exist, we call this a function which is not continuous. Function value does not exist. However, the full limit value exists. Equals to function is not continuous. Fx not continuous. Is that okay? Then when can you be continuous? You can only be continuous when you satisfy both conditions. Function value exists. Full limit value also exists. That's the formal way to define it. Okay? So fx is continuous. I'm going to introduce this symbol. It's called if and only if. It means you assume this is true, you can conclude the other guy. You assume the right side, you can also conclude the left guy. But what's the right side? It's the condition that lim of fx as x approaches, okay, as you define the domain, is continuous at x equals to a, where a is some fixed constant. If and only if the limit of fx as x approaches a, just now we saw 5, right? Just now we saw 5, you see? Limit as x approaches 5, I just changed the 5 into a. Is that okay? Just some number. Exists the full limit. This is called the full limit. Not the left limit, not the right limit, but the full limit exists. Singular, so plural. So I should put s. And logical and at the same time, you have the function value f of a also exists. This is what we call the function value. Okay, I better label it function value. Just a few more terminology. This a here is called the limit point. Just for fun only, I don't need to know. Just x approach that number, the x value. It's called a limit point. Okay. Now I introduced to you the idea of a limit as well as left hand limit, right hand limit, and the idea that fx is continuous. think you'll need to know that. Can?
Okay.
Let's try one more idea, which is evaluating limits using limit law. This one quite fast. So let's say that you got fx equals to x squared plus 5x plus 999 over x cubed plus 1. Just now, from the video, you've seen that the Prof. Leonard, he did this, right? He approximated it and he said, just say, take the highest power term, x squared over x cubed, and cancel, you get 1 over x. Right? And this is your asymptote. You remember seeing that?
Mm-hmm.
Here's how you evaluate it. What is meant by asymptote is actually you take the limit of fx as x approaches infinity. What is this equal to? And the answer is 1 over x. That's an asymptote. Lim of f of x as x approaches infinity. When x gets bigger and bigger and bigger, what does your fx approach? Let me show you how to evaluate it. Here's the trick. What you want to do is fx, you look at x squared plus 5x, 999, x cubed, and x and positive 1. Which is the highest power term? Which is the highest power term? Highest power term is?
Below. Wait, what
X
do you
cubed,
mean?
right? Highest power
Uh-huh.
term. There's how many terms here? A term here, x squared, another term here plus 5x, another term here plus 99, there's a term x cubed, there's a term light blue plus 1, which is the highest power? X cubed. 1, 2, 3, 4, 5 terms. You want x cubed as the highest power term. What you want to do with, after you identify the highest power term, is you're gonna multiply the top and bottom by a fraction. Happy face over happy face. But happy face will become 1 over x cubed, which is 1 over the highest power term. 1 over x cubed. Okay, so we're gonna focus on the numerator here. There's an invisible pair of brackets now. When you have 1 over x cubed is a single term, and inside the bracket there's multiple terms, you have to distribute, right? So let's see what happens. X squared times 1 over x cubed, that's essentially x squared divided by x cubed. Let me draw a huge fraction first. So x squared divided by x cubed. Plus the next one, 5x divided by x cubed. Plus 999 divided by x cubed. Okay so far?
Yeah.
Numerator, now denominator, 1 over x cubed times into the first guy and the second guy. So you get x cubed on top over x cubed below plus 1 on top x cubed below. Okay so far?
Yeah.
Algebra step. This one I can multiply by this fellow here because they will cancel off to become a 1. Times 1 means I don't change the value. They are still equal. They are still equal. But more importantly, now I can do some algebra. X squared over x cubed, isn't it just 1 over x?
Mm-hmm.
And plus 5x over x cubed, isn't it just 5 over x squared?
Yeah.
And then just repeat. Okay, I'm just going to use black color all the way. You get 99 over x cubed. This one cannot simplify. All divided by x cubed over x cubed is 1. This one, you're left with 1 over x cubed. Now the question is, what is the limit of f of x as x approaches infinity? In other words, you don't draw the graph. This one is using what we call limit law. So one of the laws of limits tells you that when you take the limit of f of x, let's just substitute the fx with whatever we just found. Fx is this guy, right? Can you see? Fx becomes this guy. One of the laws says that you can just, when you have a division going on, limit of a top and a bottom divided by bottom. It's the limit of the top divided by limit of the bottom. Or in other words, limit of fx on top over gx below is equals to limit of the fx divided by limit of the gx, where x approach infinity. Let me fill it in the blank. There's a hidden condition required, which is that the limit of the numerator and the limit of the denominator must exist first. But I know that it exists. I'll tell you that they exist first, so you can use the law. So you end up with limit as x approach infinity of the numerator, bracket, all divided by limit as x approaches infinity of the denominator. Can you see? The limit gets distributed.
Mm-hmm.
Good. Then now you can distribute further. Another law says limit x of infinity of fx plus g of x, two different functions, is just the limit of f of x as x approach infinity plus the limit of g of x as x approach infinity. You can sort of distribute the limit into each of the terms. So we're gonna calculate each of the limits. Let's just write it down. Lim x approach infinity. I'll copy and paste this to save some time. Of 1 over x plus limit x approach infinity of 5 over x squared plus lim of 999 over x cubed, all divided by lim as x approach infinity of 1 plus limit of 1 over as x approaches infinity of 1 over x cubed. Then you can evaluate each of them piece by piece. So what's the limit of 1 over x?
Approach 0.
Approach 0. So the value 1 over x as x arrow infinity means get closer and closer to infinity. Then 1 over x will approach 0, arrow 0. But when we say the limit, we have to take a leap of faith. We have to believe that eventually at the very, 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 very biggest positive number x,
Okay.
1 over
0.
x will be exactly equal to 0. Yes, correct. The value 1 over x will never be 0. It will be always slightly above, but the limit at infinity must be exactly equal to 0. Do you get the difference?
Yeah.
Oh, 0.0001 is still not 0. Oh, that's the value of 1 over x. But here we're talking about the limit, which means you sub in x with essentially infinity. I know you cannot actually do it, and infinity is not a real number. It's a concept. It's a number it's a value which is bigger than everything else. You cannot substitute into expressions. But the limit, whatever is the definition of a limit, we don't talk about it yet. It will just eventually become 0. So you can replace it with a 0. Okay. Plus next one, 5 over x squared.
0.
0. Next one,
Plus
9 over x cubed.
0.
Also 0, all divided by
1.
This is 1 plus
0.
0. Okay, good. Yeah, so that means that the limit will just be equal to 0. Right? Let me think. That's evaluating the limit. Eventually it becomes 0. Sorry, there was a mistake here. No, this is not correct. This one is already taking a limit as x approaching infinity, but the asymptote is, this is not correct. No. The limit of fx as x approach infinity, this will be equivalent to the limit of the asymptote 1 over x as x approach infinity. How should I put this? This idea of approximating it with x squared over x cubed gives you the asymptote. You're just thinking of it like this. X cubed is power 3, x squared is power 2, right? Then power 3 will grow a lot faster compared to power 2. Do you agree?
Yeah.
Eventually, when x gets very, very big, the constants here, plus 99, and the 5 times x, right, it actually becomes insignificant. I know that if you sub in with 1,000, 5 times 1,000 is quite big. But if you compare it to, let's say, 1,000 square, that's 1 million. It's way bigger. So that means that these smaller power terms actually don't matter in the long run. When x gets very big, even if it's 1 million, right, 5 million is very big, but you must remember there's also an x square. 1 million square is 10 power 12. It's way bigger than 1 million. So that means that the lower power terms, you can ignore them. So you just focus only on the higher power terms. Does that make sense? Okay. That's why he concluded with just x squared over x cubed. Then you divide, you get 1 over x. Yeah, but this is evaluating limits by doing this trick. Let's pause a while and let me show you just for fun. Okay, maybe for the homework, I'll give you some questions on limit laws. Okay. Then you can try and calculate. And I'll send you more lecture videos to watch. I think it's more useful. Okay, delete this. Okay, let's try. Can you see the shared screen?
Yeah.
This is Spider. You can use VS Code if you want. So whatever is your favorite IDE. So let's try and define a function. Okay, usually programming, you will not have such fast. You will not code so quickly. If it's something significant, you will have you will spend most of your time planning how to write. So this one is a simple example. I just want to show you how to type up a piecewise function using Python. So let's say you have a function, we call this piecewise. Okay. Then is it clear? Okay, I zoom in a bit. Piecewise. Then what you want to do is type in an if function. If you have a x that is less than 2 divided by 3, right? Then you can calculate the function. 3 times of x, subtract away 2. I put on return. Okay. I should probably put a pair of brackets. Is it safer? I think I don't need the brackets, but it's okay. And else this one will be the opposite of 2/3. Because I have only 2 cases, else will cover every other case when x is not less than 2/3. Okay, the less than symbol here is a logical less than. If I really want, I can also type in else if, and then I type in the condition x more than or equals to 2/3. And then I want to return the other function, which I have defined previously as x. But what is x? You see there's an error message. You say undefined name x. So that means in my function here, I need to put in x. If I don't want to call it piecewise, I can also call it f of x, make it more mathematical. So now that I've defined the function, I can type in print f of, let's say I want positive 5. When x equal to 5, what will it return me? When x equal to 5, you will read the code. X is 5 now. So which branch will you enter?
Else
Is it
if.
less the else if branch, right? Because it satisfies this condition. Then you're going to return x, which we already substitute with 5. So it's going to return a 5. So let's print it and see. Oh, what do you see? 5 here. You see? Is it? You see 5, okay, good. What if I type in, let's say 2/3 is around 0.6. Let's type in 0.5. What will it give you? Which branch will you go into?
The first one.
The first branch, right? Then return 3 times 0.5, which is 1.5 minus away 2, which is negative 0.5. Let's see if it gives us negative 0.5. Run. Oh, what do you see? Negative 0.5. And so that is a function. Or you can call it any other name you like. Hello function. Whatever you want to call it. Then you just have to rename it. They'll tell you an error. Undefined name f. Then you must change it to the correct name. Hello function. Oops. Just print it. Let's try the same function. Value 0.5. Then we still get negative 0.5. Okay? Can?
Yeah.
Good. Right. So piecewise is just coding. Piecewise functions is just coding. Yeah. You can make as many conditions as you want. Okay, good. Okay, let me see. Let me look at the things you need to study again. Let me take a look. Oh, the prerequisite questions, right? Right, maybe I should go through those. Do you need to rush off?
I don't.
Okay, I also wait. Okay, can. Let me go and download the files first. Right, let me just send you the code. You can go and try it on your favorite programming software if you want. Let me go and download those questions. I think there were most of the questions you should be able to answer already, except for some of them. Let me show you how to solve them. Okay, give me a second to download this. Where is the file? Um, 2, 5, and 9, right? It's fine. Page showing. Oops. Yeah, so it disappeared. Okay, so for page 2, 5, and 9, right? This question 1 should be okay. Question 2, maybe you cannot solve because I never really teach you before. Modulus. Okay. I think I've taught you before, like how to solve modulus equation. Like for example, if it's equals to 3 like this, change into plus minus, right? X plus 1 equals plus minus 3. So x plus 1 equals negative 3, or x plus 1 equals to positive 3. Bring over, you get minus 4. Bring over, you get positive 2.
Okay.
Oh, by the way, did you know modulus is a piecewise function? I mentioned this before, yes? Oh.
Okay.
It's x plus 1 when x plus 1 is positive. It is negative of x plus 1 when x plus 1 is less than 0.
Okay.
Right? That's why you have, because of the plus minus, that's why shortcut is to just keep it as x plus 1, but you cross multiply the minus over. So that's how you get plus minus on the right side. But what happens when it's an inequality? Not that simple anymore. You need to remember this idea. Modulus of x less than, let's say for example, 7, it implies, actually if and only if it's equivalent to negative 7 less than x less than 7. Okay. Why? What does it mean? So draw the graph. How does modulus x look like? It looks like this. Can? Where is 7? It looks like this. Y equal to 7. So they intersect here and here, which is at negative 7 and positive 7. Then the question is, modulus x less than 7, right? Means which part of the graph is the triangle looking modulus x function below the 7? Clearly, it is this yellow part here. Right?
Yeah.
But we don't care about the yellow function itself. We care about the shadow, which is the bottom part here. So what are the values? Isn't it just negative 7 less than x less than 7? Can you see that?
Yeah.
Okay. Those are the x values that result in the yellow function being, the yellow part of the modulus x graph being below y equals 7. Okay, but this is just the general idea. The algebraic idea is this. You see less than symbol, now you have inequality. Minus 7 less than x less than 7. If you change it into a 9, what happens? Then you just be
negative 9 less than x less than 9.
Very good. Yeah. If I put in an equal sign now, then you put equal for both of them.
Okay.
If I change the x into anything else, in this case, x plus 2, then it will just be negative 7, positive 7, but less than equal, less than equal. In between is
x plus 2.
Exactly. Then how do you solve? How do you solve for x? Plus 2 go to no plus 2. Minus 2. So you have to minus 2 on the middle, in the middle, as well as on the left and on the right. Minus 7 minus 2, you get negative 9. 7 minus 2, you get 5. Less than equal, less than equal. Okay? Is that okay? Very good. Then that's your answer. Ding. But how about we consider one more case, which is that if the inequality is in the opposite direction, modulus x more than equals to 7. This is equivalent to, what is it? Let's think about it. You want more than equals to 7 this time. I copy the whole graph, but I want more than. Then what do I do?
Here and here.
Huh? More than. So that means that you want which part of the graph instead? Sorry. Yes. Correct. And there's also a left branch, right? So it's this part here and the left part. What's the corresponding shadow? This part on the left, this part on the right.
And negative 7 or x more than positive 7.
Exactly. That's it. Also, you introduce a negative sign on your own. So let's look at this. We write it as x less than negative 7 or x more than positive 7. Oh, sorry, there's an equal sign, you must put equal. Have equal, you follow the equal sign. So this is one step. You cannot, you struggle with this first step, then the whole question gone. You need to know how to do this first step. Okay, then let's say we make it more complicated. Let's say it's x squared minus 9 modulus more than equals to 2.
Then x squared minus 9 less than or equal to 2.
No? What do you introduce on the left side on your own?
Negative 2.
Less than or equals to negative 2? Or
X more than
not x
x squared minus 9 more than
or
2.
equals. You have
Ne-
equal sign, must follow the equal sign. Which one?
More
Sorry.
than or equal to 2.
Very good, exactly. That's it. Then now you have a quadratic inequality to solve. I think you know how to solve this, right? Yes, you know how to solve. We write as square root 11 squared. Then you can factorize as x minus square root, x plus square root. Please don't go and bring the constant to the right hand side. Right, then how to solve quadratic inequality? Just x times x positive. So you draw a happy face. You have a negative root 11, positive root 11. Then from there, less than equal means negative root 11, less than x, less than positive root 11 for the left half. This other half, minus 9, same thing, minus 11 more than equal. So this time it will be the opposite case. Blah, 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 blah. You'll end up with x minus root 11, x plus root 11, but more than or equal to 0. Which means that you'll do the opposite answer. You have the opposite answer, x less than, oh, I forgot the equal sign, or equals to negative root 11, or x more than or equals to positive root 11. Is that okay?
Mm-hmm.
Yeah, that's for this example. Let me add a page and bring the working down. That's the theory you need. Now let's solve this question. How to solve? Modulus 8 plus 13x less than equal 5.
Okay. So okay.
A can be any number. Whatever is in between the modular sign, keep in the middle. Good. You can split it. Write it again. 8 plus 13x less than equal 5. Oh, it's not all, it's n.
Oops.
In this case, because it's a chain. Do you need to change the direction of inequality here? From 13x to x?
No, because I'm only dividing by 13.
Yes. Divide by a positive, don't need to change. Only when you divide or times negative number, then you have to flip inequality direction. And now combine into one answer. Okay, good, you got it. Okay, very good. Yeah, so how about if I change the direction to more than equals?
Okay. If like this, then it is x x less than or equal to minus a, or x more than or equal to a.
Correct. Correct.
Okay.
So the A is not.
Wait.
Or. It's a or. Or is correct. Or you could just write it one time and then don't need to write it. Can, yeah, okay. -3. Huh? Yeah, got it. That's it. Okay.
Okay.
Good. Okay, how about the next question? Let me see. 2, 5, and 9. Okay, let's go on to question 5. Question 3, okay, no, actually. Question 3 is a simultaneous equation. Can you see? You sub in 1, 14, you get an equation in A, B, and C. You sub in 2, 84, you get another equation in A, B, and C. You sub in 3, 114, you get another equation in A, B, and C. Then from there, you solve simultaneous equations using 3 equations and 3 unknowns. Do you know how to do that? Question 3 also maybe a bit challenging. Do you know how to use a calculator to help you? Let's say let me design some questions. X equals 1, y equals 0, z equals to -1. Then let's say 2x minus 3y plus z. Then this will give me 1. And then I give 4x minus 6y plus 3z. This gives me what? Times 2 plus a z. So 2 and then minus 1. That gives me a 1. Okay, and then I say I have 3x plus y minus z. This will give me, I don't know, 3 plus 0 minus -1, which is 4. Okay, let's say that you are starting with this equation and you didn't know the answer is x equal to 1, y equal to 0, z equal to -1. Or let's say you pretend you didn't know this as your answer. And you start with this question. Can you solve for x, y, and z? I never teach you how to solve this. But do you know how to use the calculator to help?
I know you can press on like the simultaneous thing.
Correct.
Then
Yes, that's
select
exactly
number
it.
of unknowns 3.
Yes.
And then it'll show like this. And then you just show it 3 times.
Yeah.
Yeah.
Yeah, that's all there is. So this question instead of x, y, z will be a, b, and c. Oh. So you just have this equation of a parabola, happy face. Let's assume it's happy face. You have a point 1, 46. You have another point 2, 84. You have another point 3, 114. You just have to sub in the x, sub in the y, x and y. Right, x is 1, y equals 46. You sub in, then you get an equation in a, b, and c. A second one and a third one. Then from there, you type in the calculator the coefficient of A, coefficient of B, coefficient of C. So instead of x, y, z, it will be A, B, and C. So for example, 2A minus 3B plus C instead of x, y, and z. Does that make sense?
Mm-hmm.
Okay, then you just type in. Okay, maybe I just show you on a scientific calculator first how to type. Okay, let's say that you have a scientific calculator here. You can solve simultaneous equations, 3 equation, 3 unknown. I already sent you the equation, so yeah, you can go take a look. So if you go to, let's say, equation, you have this option, maybe a bit different on your calculator. Number 2 is the option you want. ANX plus BNY plus CNZ equal DN. So you click number 2, you get A, B, C, and then D. Not to be confused with the coefficients. I mean with the variables. So in this case, I have 2x minus 3y plus 1z. So I type in the first row 2, and then -3, and then +1. And then there's a D. D is a constant on right hand side, so it's a 1. Then you go on to the next one, it's just 4, -6, positive 3, and then 1, and then finally 3, 1, negative 1, and then positive 4. Okay, that's equal. Then it will calculate for you. X equal to 1, y equals 0, z equal to negative 1. Okay? Is it clear?
Yeah.
Okay, okay, now time for GC. Let me share the GC this time. Let me see. I have. Oh, this GC doesn't have. Wait, nope. I need to use another GC. Doesn't have the app. Thanks. Hold on a second. Where did my calculator go? Ah, there it is. I have to use Webbit Emo because the apps is not available in that other one. Okay, can you see? Calculator. Yeah, so you go to APPS apps, then there is something called number 4, poly simultaneous number 2. Polynomial root finder and simultaneous equation solver. We don't want the polynomial, we want the simultaneous. This is simultaneous equations, but how many equations? 3 equations, right? So you select 3. How many unknowns? X, Y, Z, right? So you select 3. You can select the output to be decimals or fractions. Then you can select the output to look like normal numbers, or you want scientific notation or engineering notation. Then this one, you can select the number of decimals you want. I'm just gonna choose float, doesn't matter. Then if you're keying in sine of something, cosine of something, tangent of something, do you want to type in degrees or radians? You can also choose the option. It's not relevant to us, so we just go next. So the coefficients you can key in, like for example, sine 30, this will give you half, right? Because they are calculating in degree mode. If you ever need to type in sine, okay, but let's just key in the actual numbers we need, which is, what is it? Let me see. System matrix just means the coefficients, okay? So you must follow the same order. I hope you do have the photo already of the system of equations?
Yeah.
Have, yeah, just type in. So what we have is the coefficient. Just type in accordingly. 2
minus
negative 3. Then after that is positive 1. Then after that is a constant 1. It's the same thing as the GC. I mean, same thing as the scientific calculator. Negative 6, positive 3, positive 1. Next one is 3, 1, it's a negative 1, and then it's a 4. Okay? Good. Let me double check if I got everything right. Okay, good. Then I just solve and I'll get the same answer. Okay? The most important thing, you can so convert. F and D means fraction or decimals. Okay. Good. Does Gaussian elimination sound familiar to you?
No.
No, okay, you probably don't need to know it. You only need to learn in uni. I only learned it in uni. Then I won't teach you. Yeah, so use the GC to solve.
Is it possible to solve it manually? Or is it like need the...
Yes, you can solve it manually.
But it's just very long. Or
It's just very long,
it's the same way you would do it if it was 2 unknown and 2 equation.
Yes. But
Okay.
you probably, but because it's so long-winded and you may get confused, there's a standard strategy called the Gaussian elimination.
Okay.
Gaussian elimination. The trick is to use elimination by, you take the first equation, you multiply by some constant. The second one, you multiply by some constant so that they are the same coefficient for, let's say, x. You go in order, x, then y, then z. So we try to take 2. Let's say we take this equation, you multiply by 4 over 2. Why do I want to do that? Because 4 is what I want, 2 is what I don't want. I end up with 4x minus something, something, y, something, something, z equals to something. Then I take that, I subtract away from equation 2. This helps me to eliminate the 4. You get the idea?
Yeah.
But then you keep the first equation. And then you keep the first equation, you can multiply by 3 over 2. You get 3x and some other things. You take that, you subtract away from the third equation. You also eliminate the 3x. So eliminate these two, and then you'll get something in terms of y and z's only. Then after that, you go in a staircase shape. Go in a staircase shape. So how do I phrase this? How do I draw this? Something like this. You'll be left with a x, left with a y, and then left with a z. How do you left with a z? You got something in terms of y and z already. You're gonna multiply it by some constant, some happy face, and this resulting expression you go and add or subtract, depends on you, to the equation 3 so that the y gets eliminated. Then you end up with only a x in the first, x, y, and z in the first equation, but only y's and z's in the second equation. And if you eliminate this, only a z in the third equation. Then from there, you can solve for z. Then you can do what's called a reverse substitution. You just sub back in the z, you can solve for y. Then you'll be able to solve for z and y already. You sub it back into the very first equation. Then from there, you solve for x. Does that make sense?
Okay.
I never explained in detail because it's Gaussian elimination. Is it a
okay.
prerequisite? I don't remember seeing it.
Nah, it's okay.
Then don't wait till uni
I
then
was
learn.
just curious.
Use GC to solve. You can go and Google this Gaussian elimination. They will explain to you in detail. They will introduce ideas like pivot or leading term. Leading term. That's the idea of a staircase and echelon. Row actually R, REF, and REF. I don't have enough time to explain this. I'm not gonna talk about it.
Okay.
Row echelon form and reduce row echelon form. Echelon is an airplane, it's a diagonal shape, staircase shape. Not now. I don't think it's relevant now. Let's look at the question 5. What is that? Question 5 is this one you should be able to do. Okay, try first. Question 5, let's see. So find fx plus h minus fx over h. Actually, I explained before something similar. Do you think you can handle it now? You've done the practice stuff. Right. Just replace the x with x plus h square, right? Then just expand. Right, everywhere. Okay, then I'll skip this question. I don't talk about it. I think question 9 was the one I think was interesting. This one exponential should be okay as well. Just simultaneous, okay? Sub x sub y, then get two equations in terms of a and b, then solve for a and b.
Okay.
Right, good. Question 9 is interesting. Let's see. A triangle has vertices point A, point B, point C being A, comma B, C, comma D, and then E, comma F. So using only algebra in terms of A, B, C, D, E, F, that the lines, you want to prove that the line segment connecting the midpoint of any two sides, A, B, B, C, or AC. So let's label the midpoints. It's here, here, and here. Is parallel to the third side. So what is XC? I have no idea.
Or I just ignore it.
Okay, can. They tell you that the line segment connecting the midpoint of any two sides. So so there's 3, right? There's this one, the blue one. There's this green one, and I ran out of colors. Maybe I'll use black. And this one. These are the 3 lines they're talking about. They are saying that it will be parallel to the third side. So, so this blue line will be parallel to the bottom. This green line will be parallel to the other side. This black line will be parallel to the other side. I think it's quite convincing from my drawing, right?
Yeah.
Okay, but you need to prove it. So how do you do it? I think they are giving you a clue with it. Prove the line segment is also equal to 1/2 the length of that third side. So in order to this is extra credit. Okay, extra credit. Okay, extra. I got it. So all you need to do is to prove parallel. So when you have parallel lines, what's so special? The gradient is what?
The same.
Parallel lines, gradient is the same. So this is coordinate geometry, right? How do you find gradient of this line? Let's just call this MAC. I'll call this MAB, midpoint, M for A, midpoint. Midpoint of BC. Okay? How do you find the midpoint of AC?
For x coordinate is A plus E divided by 2. Then for y coordinate is B plus F divided by 2.
Then we just find all the others. Just do it. MAB. So point A and point B, A plus C divided by 2, then B plus D divided by 2. Okay. How about MCB or BC? I should be consistent.
E
BC.
plus E over 2, then D plus F over 2.
You know what? Let's just try and be alphabetical. Instead of E plus C, I put C plus D in case we get confused. Okay, good. Because there are a lot of letters going on. Try to be systematic. It's not difficult to follow. Then how do you find the gradient? Okay, how do you find the gradient of, let's say, the blue line and this BC line? Let's focus on this pair first. To prove they're parallel, we need to find gradient and gradient and show they are equal. Right? So let's work out what is the gradient of blue line.
It would be you take the Y.
So maybe it will be smarter if we transfer the information over. Wait, give me a second. Duplicate this, shrink it down. I need a bigger diagram. Okay, MAB, put it over here. MAC, I'll put it over here. MBC, I'll put that over there. Then you can see the X and Y coordinates easily. So what minus what? Y minus Y, right? So we focus on this blue line. So it'll be B plus D over 2 minus AB plus F over 2, right? Do you get it now?
Yeah.
If you want, you can label X1, Y1, X2, Y2. Then it's Y2 minus Y1, followed by X2 minus X1. So A plus C over 2 minus A plus E over 2. Can multiply 2 over 2. Actually, let's not do that. Let's just add together. Fraction minus fraction make what the same? Denominator the same, right? So it's already denominator 2, so you can just combine to a single fraction. You get B plus D minus B plus F. Correct or wrong? Wrong. What's wrong?
Wrong, no bracket.
Very good. There's a pair of brackets here. You need to distribute the minus sign. So you end up with minus B minus F. Then all divided by the other guy, same thing. A plus C minus A minus E. Oh, must have a minus E, not plus, bracket. Yeah, better write my E nicely. So many letters, very confusing. Better make sure my handwriting is on point. So here over 2, then you can just multiply 2 and 2 at the top. They'll cancel off. You're left with, actually, before you even continue, let's just cancel off B minus B, A minus A. Then we are left with how much? D minus F at the numerator divided by C minus E at the denominator. Is that okay?
Yeah.
That's M blue. How about my M BC? Gradient. M, little m means gradient. Capital M means midpoint. So M of BC.
D minus.
Not to be confused with capital M, okay? It's capital M.
Yeah. D minus F over C minus E.
Yeah, and then it's the same lah. So I think they are parallel. Since gradient of the blue line equals to gradient of BC, this implies that blue is parallel to BC. Then you just repeat for all the other pairs. Find the gradient, show that they're the same. Oh, very long-winded. I don't want to do. You do yourself. Black and red. Just to find the gradient, show that they are equal. Okay. Good. Okay, that's about it. I think the rest you should be able to do. You know what's a secant line? Secant just means you go and draw the curve. So down, down, up for cosine. X equal pi over 4 is somewhere here. You have a point here. And x equal 11 pi over 6. I have no idea what is this. 100 pi is 180. 180 over 6 is 30. 11 times 30 is 330 degrees. So it's somewhere here. 270, 360, so 330 somewhere here. Or 11 pi over 6. Then they're asking you to, this is the point. They're asking you to connect the dot like this. And then find the equation of the secant line. It's not a horizontal line. Oh, so y equal mx plus c. You go figure it out. Okay, so your homework, I guess you should do this period paper. Do all questions.
Okay.
And then I'll give you some practice questions on minutes.
Okay.
And I'll also ask you to go and watch the videos.
Do you want me to do questions for graphing and the conics also?
Actually, I think, do you want to do? I think actually quite simple.
Okay, okay.
Maybe we cover more things. Let me see. There was some more. This one you haven't watched the video, right? There was one concept about the converting to polar form. Like you have 2 comma pi over 6. You want to convert this into root 3 comma 1. One of the interesting graphic design questions. Convert the point to rectangular coordinates. This is polar, they want rectangular. This is to find. This is given. You haven't watched the video, right?
Nope.
Okay. Go and watch that video then. We can talk more about that. Okay, maybe let me think. Okay, you should actually try more questions on conics, right? Because that's your basic prerequisite. Polynomial, rational, exponential, and logarithmic functions, graphing transformations of families of functions, conic sections, inverses. Right? Okay, I'll go and give you some questions, I think.
Okay,
You just
okay.
pick this up. Okay? Or type it up. And that will be all for today. And thank you. I'll give you some limits exercises.
Sure, sure.
Can.
Thanks.
Bye-bye.
Bye-bye.